Start my recording. All right, so if you're following along at home, we're going to go to the section in our training manual. From the table of contents, it's down after our second exercise where it's at point groups. The next section is surfaces and contours. So we're going to jump to that page. It is on page 18, the printed page number at the bottom of your PDF file. It's actually the 24th page in the PDF file, but it's printed page 18. And we're going to talk a little bit briefly here about how surfaces are made and how we can make them better and how we can verify them and make sure they're made correctly. Most of that knowledge, though, is going to come a lot easier simply through doing. So we're going to get a chance to work on some data, a really nice data set that you can get a sense of how these things work and their interdependencies. So basically, without reading you all of this stuff, but when you get a chance, do go back and read it. It does talk about some important concepts, but we'll go through this as well. So basically, what we're trying to do is fill out a drawing that represents a, um, you know, a part of the earth, part of our, our site is like a little slice off the earth there at some point. And we're trying to represent that as a continuous uh, sort of fabric, if you will, as if you had draped, a mesh over top of what the ground or other things that you are trying to add to that surface might look like. Okay, so we're trying to model that layer of information. So what do we have in our typical drawing is we've got, line work. We've got things that typically only represent the edges of things. And sometimes we might have some points out there by themselves that represent the elevations of, specific point locations. But what about what's in between all those, just in the blank parts of our drawing? And if you're just looking at the drawing itself, there's nothing there. And so we have to come up with a means of filling in that blank space. Now, Will, you've got SolidWorks experience under your belt, so you know a little bit about modeling solids, and I would dare say also surfaces like meshes and things. And the same thing is really going to apply. We're going to technically generate um, a mesh, but it's a particular kind. And in the case of modeling the land, we're not going to be allowed to have any vertical or what's called supra-vertical, or in other words, more than vertical uh, surfaces. So if you had something that you need to model that's like a vertical wall, or maybe, another example might be the face of a curb, we're going to need to remember that we have to lean the top part of that structure back to the high side just a little bit because of the way the mathematics works on these models. And it's not that it can't model it with the mesh. You do that all the time. If you think about, modeling a teapot, which is probably one of the examples you may have learned on, Will, the the bottom part of that teapot is underneath parts of the top part and they curve back under. So the mesh itself can be modeled correctly, but you can't compute volumes using these prismatic methods that we typically use between surfaces. So it's just a very complex reason why, but just remember the rule there is we can't have any vertical edges, and we have to get as close as we can, but still lean them back just a little bit. And you'll get used to doing that kind of thing as we go along. Now, when we're trying to model the space in between where we have information, what we have to try to do is to figure out what the ground does in the intervening spaces. And it essentially does a process like what you see in this little picture here. Is it goes to, pretend that those lines are not drawn yet. And it goes to every point in our selection set, and it sits on each point, and it looks around itself 360 degrees, and it tries to find or connect to other points. And if it finds one with nothing in the way, nothing in between it and the other point, then it connects them with the line. So if you see in our little four-sided figure, let's assume that the computer is sitting on that 110 elevation point in the southwest corner. It looks around itself, and the first point it sees is up there, basically north of its location at elevation 100. And so it connects a line which will become an edge of a triangle from it up to that 100 elevation point. Now, and the assumption is then that with the lack of any other information in between that the ground changes linearly along that line. So it goes from 110 to 100. So halfway down that line, it would be 105. Okay. Then it continues looking around, and it sees the point in the northeast corner there at the same elevation of 110. That's fine. It can be the same elevation. And so it connects an edge up there because there was nothing in the way yet. Keeps looking around, it finds the point basically to the east of it, connects the line there, and it doesn't see any more points. And so it's done. Then it moves on to the next point. Maybe it goes up to the north point at the 100 point in the northwest corner. It sits there. It starts to look around itself. It first sees the point over to its east at 110. Okay, nothing in between yet. So it draws a line. And again, all of that's happening in memory. So it draws a line from 100 over to 110, connects that up, keeps looking around. And even though there is a point down in the southeast of an elevation 100, the point in the northwest where the computer is sitting right now can't see that point because there's already a line that's been drawn between the 2 points that have elevation 110 from the previous point when it did it. So that line's in the way. So the northwest point can't see the southeast point. So therefore it does not draw a line to that point. Continues to look around, and it sees the point down below it at 110, but there's already a line connected to it anyway when it went from the other direction. So it's done. It moves on to the next point. It's sitting on the northeast point. It looks around itself, and it sees the point basically south of it and connects a line there. The point back to the west of it has already been connected from when the previous point was done. And it looks down, keeps finding, it sees the one down at the 110 at the southwest corner. And there's already a line connected there. So really the only line it was able to connect was down to the southeast point. And then it moves on to the next point, sitting on the southeast point, but there's already things that are connected to everything that it can see. The only 2 points that it can see are the southwest point and the northeast point. They've already been connected, so nothing for it to do. It can't see the point in the northwest corner, so it doesn't connect. Now,
Ken, uh, sorry
Yes.
to interrupt, but are you in Carlson right now? Like
No,
drawing
no,
something out?
no. Did
All right.
I, have I
No, no,
shared?
it just seems like I didn't know if we were all still looking at the okay.
Yeah. Yeah.
I was worried. I was like, this doesn't seem right. I hope I'm seeing the right screen.
Can you see that little figure, that little,
Yes, yes, I can. It just I
yeah. So I was just talking about the process. We weren't watching it happen. There we go. Okay. So let's say the computer sits, pretend none of the lines are there. It sits at that first point at 110. It looks around and starts connecting lines to all the points it can find. It finishes, goes up to the next point, and it starts connecting lines to the points it can see. But since there's a line in between it now, it can't connect. Oh, let me do this. I forgot. Put this on so you can see my cursor a little better. So if it's sitting down here, it looks around itself. It can see this point, connects a line. It keeps looking around itself. It finds this point, connects a line. It sees this point and connects this line. And then those are the 3 points. It's drawn those 3 lines. It then goes to the next point. It does the same thing. It looks around itself. So it sees this point, it connects a line. It sees this point, but it's already got a line there, so nothing to do. And it can't see this point because there's a line already that has been created in between it. So that line across the top is the only line it can make. Then it goes to the next point, maybe this one. It looks around itself. It finds this one, connects a line there. The other one it can see is this one here, but there's already a line there. It can see this point, there's already a line there, so that none of that needs to do. So it only connected this line here. Goes to the next point. It looks around itself, it sees this point that's already been created. It sees this point that had already been created. It can't see this point because this line was created in a previous step. So it can't connect across that line. It can't go across that line. Okay, so if you think about what this figure represents, pretend you're down on the ground and you're walking along and you see this and you're standing on this point. Now we make these triangles to represent the little piece of ground that connects those points together. And they're going to be irregularly shaped. Okay, they will be triangles, and we use triangles because it takes 3 points at a minimum to define a plane or a piece of a plane in three-dimensional space. So that triangular slab there has been made, so is the one over here on this side. Okay, and it has those changing elevations at the corners. Now, what would this feature actually look like if I'm standing down here at this southwest corner and I'm at an elevation of 110 and I could walk all the way across this line here to elevation 110, and that's a constant elevation there. So that would be like walking across, something. In this case, it would be a ridge because off to the left or to the northwest, it falls down to 100. It does the same thing here. To the southeast, it falls down to 100. So that would be what's called a ridge feature, and with low points left and right. Now, consider those same points. I'm going to go to the next page. And again, pretend the lines have not been drawn yet. And so maybe it started up here at this point. It looks around itself. It can connect that point over here. So it does. It sees this point. Nothing's there yet. So it connects a line there. It sees this point, connects that, and on around, just like we talked about before. Now, what does this figure represent? And again, I'm going to be walking along these edges. So if I'm walking down this edge, I'm down here at 100, going all the way across to 100. But as I walk from the upper left to the lower right, I look up here to my left toward the northeast, and I see a point that rises up 10 feet. And the same thing happens as I'm walking that line. I look to my right or toward the southwest, and a point rises here. So this is as if I'm walking down a valley and it has rising slopes either side of that valley line. Whereas the previous picture, that line between the 110s got created first, and it forced that land into being as if I'm walking on a ridge top that falls off 10 feet to the left and 10 feet to the right. Either one of those interpretations, either that one or this one down here, either one of those interpretations of that land in that area with those 4 points is a valid interpretation based on there being nothing else that it's looking at. If it can't see anything else, it can't see any lines or barriers. And so that's where we're going to talk about this concept of a break line. And we first start talking about these break lines. By the way, that and there also talks about this 10 file or a 10 extension of the file. It stands for triangulated irregular network. And that's because it's all of these irregular triangles stitched together into a network. Okay, and so it treats those as little planar sections. All right, so right here, every triangle edge that forms is understood to be linear change or a constant rate of changing in elevation. And because of that, if any 2 points do not lie along a straight line, change in grade, if there's something else in between them, you have to separate them with a break line. Now, when you don't have break lines and you let the computer just build the edges, these edges all become break lines as they are being processed. But if we know from our surveying out in the field that these 4 points do not represent that ridge, but they do in fact represent this figure, which is that valley, then we have to draw in this line beforehand, before we try to model the point. So if that line is already there, that keeps my point 110 from looking across and seeing my other point 110. That forms a barrier or a break line. And see, there's what figure 2 says, break line added manually to force the triangulation to go in the opposite direction. So that would make it into this valley instead of the ridge. Okay, so that's what that discussion says. Now, what are break lines and how do you know where to put them? Well, in school and everything, they tell you about, well, break lines represent a break in grade. Well, okay. What does that mean? And I used to be really confused on this concept because I would think about, if you think about, for instance, running cross sections across a stream valley. So you start up on the flat side, on one side of the stream, you get a point there, you go around to where the bank starts, you're at the top of the bank. So you grab a point there, you go down to the bottom of the bank and you get a point at the bottom of the bank, and then you go maybe get a point at the bottom of the creek, and then you come back up, get the other side, bottom of the bank, go to the top of the other bank, and then over to the flat part on the other side. So to me, I was thinking about this sort of 90 degrees out of phase because, to me, that line that I just walked, I walked from the flat to the top to the bottom, or to the toe, and then to the bottom of the stream, to the other toe, to the other top, to the other flat. I said, that's a line that has a break in grade because it breaks from one point to the next point, and then it changes elevations, and therefore it drops down to the break in grade. But that's not the break line that they're talking about. They're talking about the lines that I'm crossing, not the line that I'm walking. So as I walk and I hit the top of the slope, there's a line that runs all along the top of the slope, and that becomes my break line because that's where my grade breaks from one side of it to the other side of it. I go down the slope, I get to the toe of slope, and that represents, where the grades are all coming down into it on one side, and then they change grade. That's my break in grade on the other side. So it's a direction. But what this really means in practical terms is right here. They're nothing more than edges. There's your little light bulb and your little notepad. And so here is your rule of thumb. If it is, like I said, these things are nothing more than edges out there on the ground, like the top of the slope, the toe of the slope. So the rule of thumb is this: if it is an edge on the ground, then you need to draw in those edges and connect all the points that represent that edge with a three-dimensional polyline, and you create that edge in the data, in the drawing, before you try to triangulate the data. Then that will prevent points on one side of that edge from looking across and finding points on the other side of the edge. Okay, now we're talking about finding points, and those points can be, just like we looked at yesterday, Carlson points that we've surveyed, or they could be CAD points in the drawing, or they can also be all of the little vertices of any other kind of drawn line work. So those also serve to be parts of triangles. Okay. So any kind of a point data is what's going to go into making up all of our surface, and we build triangles out of those points, but we connect lines between all the points that are a similar type feature. And so this is probably best illustrated down here's my little this is my preferred example to show you. Excuse me, because I see a lot of surveyors do this. And they'll go out there, let's say we're going to survey this curb. And they'll go out there, and what usually happens is they'll get more than just 2 points at each location, but they'll go in one spot and they'll shoot the back of the curb. They'll walk up and shoot the top of the curb, then they'll drop over and hit the face of the curb, and then go over and hit the edge of the pavement. So they'll cluster those all together. Then they'll walk, 20 feet down the line, and they'll do that again. And they're all clustered together. Now that tends to sometimes work because the points are clustered together. They tend to form those triangle edges first. And so those tend to work, but they don't always work. And here's an example of what happens. So let's suppose that instead of shooting off 4 points, let's say we shoot 2 points along each one of those linear features. I've got points A and B that are the edge of pavement. I've got points C and D that is the face of the curb. Points E and F are the top of the curb, and points G and H are the back of the curb. And I may have some other points over here and some other points down here in the center line and such. All kinds of things going on. And presumably more points on down the line to keep representing that, these features. Now, if I do not pre-draw these 3D lines through the points that represent those edges, here's what could happen. When the computer sits on point A, it starts looking around itself and drawing triangles. Well, it might look over here and see point B, and it draws an edge there in memory. Well, that's valid. Looks around itself, maybe there's a point here in the center, it might find that would be valid. But then it looks around and it sees this point E, and it goes, there's a point, there's nothing in between, so I'm going to connect an edge from A to E, and that has ignored that face of curb because we hadn't drawn it yet. And then it looks around and it maybe draws up here and sees point G. It might connect that, and then it sees point C and it draws that one. Now that one is valid because it does change from the edge of pavement linearly across that diagonal line to hit point C. So that line would be correct. That line would be correct. So B and C would be correct. E to G would not be, and A could also see point F and point H and point D, and it could start drawing those lines in there. It just depends on the order that the computer gets to these points as to which these edges get built. And we have no way of knowing how that functions. So we could wind up with a situation like up here where you see those triangles that get formed without drawing the lines would assume that this triangle AEC would be formed, and the legs from A to C and from E to C, those are valid. They're lying in the plane of that surface, but A to E is not. So you've just filled in your gutter of your curve with this triangle. Same thing with this one back here. E to G is valid. E to C is valid, but C up to G is not. I've actually cut through my curb, so I've knocked off that top edge of my curb with this portion. So you see how those are invalid. So what we would do then alternately and ideally is we would pre-draw all of those edges. And so now they are barriers and I can't look across them. So if I'm sitting on point A, I can visualize point C, so I'll connect it. I can visualize point B, so I'll connect it. I can't see point E, so I don't connect an edge there. I can't see point G, I don't connect an edge that way. I can't look past, I can't see point F because first of all, this line has been created, but I've also drawn these lines already in place as if they had drawn, I sort of pre-created the edges of those triangles. And so all of these triangles now are going to form correctly because I forced them to lie in the plane or in the planes that they lie in. Like these edge points are actually in two different planes, the one to the back and the one down vertically. These are in the one in the gutter and the one up the face as well. So that's what we have to do, is to make sure we have break lines in place to create our triangles, okay? And so we talk about that right here, where we say that we use our break lines as barriers to see or to prevent a point from seeing points on the other side of the break line and therefore creating an invalid triangle edge, okay? And so that talks about that. And you talked a little bit about some data sources, um, where we could model some points. Here's an example of, we just got a whole bunch of points just sprayed out here that was taken from a quad sheet. And all we have are points. Well, sometimes we make a model from that. It's, again, subject to those erroneously forming triangles. But if we're modeling data across a quad sheet, we may not be interested in every little curb break. We're just looking for major landforms. And so we'll pick that part up correctly. And here's some other examples of where we, can find, some digital files or files of elevation data, remote sensing sources like from photogrammetry, LiDAR, drones, in other words, Jack, any previous digital and paper mapping that usually has contours and spot elevations on it. It can be either digital or paper. And so sometimes as engineers, we don't necessarily do our own surveying. We'll get a survey company to do that, and they'll send us as a finished product a contour map. And they may have modeled that contour map correctly. That's fine. But I don't have any information about what goes on in between each of those contour lines. And my only recourse, if I'm trying to recreate that existing surface, is to just simply read the contours, assume everything is linear between each of the contours, and that's as good as I can get it. And that gives us a whole bunch of problems that we'll talk about when we're doing this kind of stuff. Now, the, the number one rule of what we try to do is we need to evaluate our data, make sure it's correct, make sure it's going to model correctly. And we're going to see a number of tools that we can use to do that. Okay, and so right now, the biggest and best tool that you may have at your disposal, it's, the best tools available are going to be your own eyes. So we're going to look at things in 3D views, look for any spikes, any holes, anything that are visibly at the wrong elevation. So in other words, we're going to give it a visible sniff test to make sure it actually looks like what it's supposed to be. Okay, so here's an example down below, is that in plan view, we're looking straight down on it and we see the edges of these roads and then these little edges and spots out here in the ground. So I've got some brake line data here and I've got my road data and I'm looking at it in plan view. So they appear to be correctly done. Okay. But if I spin that up in 3D and if I get something that looks like this, well, that looks pretty decent because my road edges now are pre-drawn. So they're going to keep any points on this side of the road from looking across that road line and connecting to points on this side of the road. And that there you can see that's the top of a little road cut. If that, excuse me, if the road edges weren't in there, points along this brake line up here to the top of the bank could look across and pick up points on this other side of the bank, which means I'm just filling in my road cut. Okay. So that means it's important for me to make sure that those road edges are at the right elevation. Okay. However, and again, and you see this little driveway that comes across this little hill and down to this loop. That's what we're looking at here in this picture. Okay. So in plan view, it looks fine. If we spin it up in 3D and we look at it like this, it's okay. It looks good. But it could be done like this picture, where in plan view, it looks fine, but those road edges might all be at zero elevation. They have not been elevated. So even though all my brake line data looks good, these road edges aren't able to serve as brake lines because they're not up here at their right elevation. Now, any of you that have any experience with other software, there are some other softwares, and I think Land Desktop used to do this. You could you could treat those edges as what they call proximity brake lines, in which case it would see it in plan view and assume that it's meant to be a brake line. And so it in memory, it raises it up to where it is supposed, where it doesn't really have to raise it up. It just says, all you points on this side, you're not allowed to look across the points on this side and connect across that edge. But Carlson doesn't work that way. Carlson looks strictly at things that have elevation. So if it's down here at zero, or even worse, if it's at, say, -2 or 1, if it's, sitting at a non-zero elevation, it's going to try to triangulate to it, but it could be hundreds of feet away from where it's supposed to be. So that's the first thing we're going to do, is we're going to use our eyes and we're going to look to make sure that everything is in its proper place. Okay. And then once we do that, we hit the go button and let it start forming triangles. Now, here's another picture. You can't really see it very clearly, but it's the same data. You see now again, I'm rotated up in 3D, but I come around here to the edges and I come down here and then I go out here. So I've got a sort of a vacant inset on the data that is where you see here. We see all of these triangles that are, you know, more regularly looking triangles. They form out here, but there's empty space out in here. And if I don't put an edge around all of the ends of those break lines here, there's nothing that keeps the computer from sitting at that point. Again, it looks all around itself, and it can look way down here and find a point down here, find another point, find another point. So these are what are going to be called edge triangles, and they're going to be invalid because we don't really know what's going on in there. It could be that those are linear changes from edge to edge. They're probably not. So we need to also have a tool to limit what goes out in these edge conditions and these boundary conditions. And we've got a number of tools we can do that. We can give it a maximum length of triangle. So if these triangles are too long, they won't be formed. But the easiest and most effective is to be able to draw a boundary around all of our data and then use that as what's called an inclusion boundary that says, even though you see all of this data, when you get to that point there, you're going to treat that boundary like a break line, and you're going to say, well, I've got a line between this point and this point here. I can't cross that line. So those triangles never get formed when you do that correctly. Okay. So again, like I say, once we start to model the surface, we're going to evaluate it again. We're going to use our eyes. We're going to spin that thing up and verify that it's correct. So many of us will say, here, go and do the triangulation, build my surface. The computer comes back very happy and says, okay, I've done. And we'll accept that. But we need to evaluate the resulting surface to make sure that looks correct. And if it's not, fix any problem. So it's a stepwise process. We're going to look at things, fix a few things, try it again, look at the results again, go back and try it. So right here is your note to take away from this. Use your eyes, use your mind, and then use the tools to fix anything that you've done that might have given erroneous products. And then once you're happy with that surface and you know that it's right and it's good, you should be confident at that point to hand that off to the next user downstream. Maybe you're a surveying company and you're going to give it to your engineering division, or you're going to send it to another company. Instead of just giving them the contours, we're going to also give them the surface so they don't have to try to build the surface over again. And so we're going to see this next exercise. We're going to open this file and look at it, and we'll see that picture. And then it's, these steps here are going to be what we are going to go through here. So this is basically your documentation. You can look back at it if you wish as we go through it, but we're going to step through all of this and then looking at some evaluations, looking at the viewers. We'll do a little exercise of quick profile. Again, that's all still part of this process, and then we'll be ready to do this workflow that ties everything together that we've been talking about for these 2 days. Okay, so we're going to spend a lot of time in this file here. So I'm going to go back over to Carlson. Oh, apparently I left it running all night. No problem. I'll close that file. In fact, I'll go ahead and just exit the whole thing and we'll start it from scratch. I'm going to start Carlson. So go ahead and do that. And once this comes up, we see a list of our recently used files. And here's one that it was just blanked, and I might want to I gotta wait for it to finish loading. And you'll see the mouse will come back. And there we go. So now I'll just right click on that and remove that from the list because that's not going to be, maybe I'll take that out. So these are lists of my recent files. I'm not going to use any of those. I happen to see the one I'm looking for here, but I'm going to, uh, you know, uh, well, let's just take that one out as well. We'll take that out. So these are all the ones I've been working with recently. I'm going to choose open files, and I'm going to navigate to my directory, and I see that I'm in my Carlson projects. I'm in my July 10th fundamentals training class, and I'm in a folder inside of it called data sets for fundamentals class. If I open that up here, it's going to look like this right here. So I'm in wherever you stored your files, go to that folder, and you're going to look for a file called sample from T3 Global and double click it. And up it's going to pop. Now this is a file that actually came from an aerial mapping company. In fact, I used to work for the predecessor to that company here in Pittsburgh. They got bought out several times, and then the main crew spun this company off about 20 years ago or so and formed their own company just south of Pittsburgh. And they do not only traditional photogrammetry using aircraft and such, but they also have a fleet of drones and drone pilots and LiDAR acquisitions. They've got ground surveyors, they've got the whole works. So they're very experienced in creating mapping from those photogrammetric data sources. And I first ran into this company when I was working down in Virginia. I was doing some work for a company that did landfills. And so they used photogrammetry to map these landfills because it's just way too big a site to try to go out on the ground and survey. So that's how I first started working with them when the company I was working for pulled up stakes and moved out to Richmond. They moved, they stayed in Virginia, but they moved further away from me than Pittsburgh was. And so this company found out I didn't make the move to Richmond. So they called me up and said, hey, we've worked with you all these years. We know you understand this process, and we have a survey division up here. If you'd be interested, you'd have to move to Pittsburgh, of course. So, um, come up and talk to us about a job. So that was back in the early 90s. I went up there and did it. I liked it. And I've been here since 1993. Um, I joke about moving to Pittsburgh to take a temporary job, and I just never left. So anyway, like I say, they've got good experience, good know-how, and this is the type of work that they deliver. And this is actual data. Um, Let me see, which one of you folks, there's one of you. Oh, Scott, you're there in Northern Virginia at J2. And I went back and reviewed my notes and stuff, and I found where I had done the training for J2. I actually went out to J2 on a series of uh, custom classes. And, I traveled out to there and we actually had the class in your training center. And that was back in, wasn't all that far back. I think it was 2023. Um, let me take a real quick peek at that. And let's see here, J2. Let me look at the actual proposal. Yeah, so I worked on the proposal of this. Carrie Rice was who was the coordinator that set all this stuff up. Is Carrie still there with you guys? Oh, let's see now. I got to go back to my chat, I think. Is Scott? Yeah, he's still there. Yeah, yeah, he is a nice guy. And he's very effective too. Uh, he does his job very well in coordinating all those efforts. And so he brought us in. I was actually it was not long after I started this work with this new company, MSoft, which again was formed out of the people that used to be at the company that was there in Front Royal. So anyway, so this is a site that you'll probably recognize. The rest of you will probably not because you don't travel in this direction. But I'll um, I'll show you where this site is just so you can see it. I'm going to do a thing. I'm going to switch to the GIS module. If you don't have the GIS module, don't worry. We're just going to use this to pop this up and take a look at where it is. So I'm going to go and I'm going to drop a Google Earth image right on top. Well, first thing I'm going to do is make sure I am sitting in the right. Yeah, I'm Pennsylvania South. Okay. So now I'm going to go to Google Earth image. I'm just going to call it site location. I have to give it a name because it's going to make a file. I'll pick it from the screen and let's go from here. I think maybe that'll get enough. It, high resolution is unavailable at that scale, so I'll take the medium. And I'll say okay, and let's see where this might give us. All right, so there our site sits in here. Now this big loop-de-loop here, you might recognize as the interchange at Breezewood. So this is coming off, coming into the Breezewood exit. I go around the loop and I swing down here, and then down here is that little truck stop area in the filling station, and these little, there's a couple of little restaurants, and there's a little trucking company here. And then this road, that's I-70 as it now heads down in your direction toward DC. And so that's where this happens to be. So it's real live data. So we're going to get a chance to play around with it and see how they mapped it. So I'm going to take that off and put it back here. I'll go back to my survey menus. Now, what we have here is the way T3 delivers their data. And I've got all of my layers are turned on so you can visualize it. Now, this would not be a map, you know, put inside of a title block. You wouldn't actually present a map like this because this is showing all of those little white lines are all of the break lines that they put in, and they're at the right elevations. So what would usually be shown as a presented map would be this. So if you go to the view menu and let's choose freeze layer by pick. It's right down here in the bottom portion of the menu, about 2/3 of the way down the total menu. I choose that command and I'm going to pick on one of those white lines, and that is what they typically would deliver as a contour map. Now, the survey companies that do this kind of stuff and deliver these maps to their clients, sometimes this is all they give them. They just give them the contour map. And so that client, though, may need to create the existing ground, and the only information they see here are the resulting contours that came out of their processing of this data. So with nothing else going on, the only thing I have is these sets of contours to try to create my triangles from. Okay, I do see these lines down here, but if I go to the view menu, well, even before we do that one, let's just take a look at, again, those blue lines, those edges, those would represent lines that I would need to put in at the elevation. So those should be the break lines that I would have to draw in. But if I look at this, I'm going to hold the shift key down. I'm going to press and hold the wheel on my mouse, and I'm going to push it up. And you can see I'll just keep getting another chunk. And so really the only thing in this data set right now that has the elevations to it are these contours. And so all of all of this stuff down here is sitting down at 0. So it's not going to use any of that because I'm going to have that switch turned on to ignore 0 elevations. And then if I go to try to build triangles, say from all of this data, now picture what's going to happen here. It's going to sit on each of these vertices, each of these points, and it's going to try to look around and find other points. So if I'm sitting at this vertex right here, I can look around and I can see this vertex over here. Well, that's going to be valid as far as this data goes. So I'm going to go from this contour elevation down to this contour elevation, and assuming that the elevation in between those 2 points is halfway between those elevations. And I would look around in this direction and find other points as well. So then I'm going to move up to the next point, and I'm going to sit here and I'm going to look this direction, look around myself, and I'm going to see maybe this point is visible, and so I could connect that. That would be valid. This would be valid as well, but I keep looking around myself. What else can I see from here? I can look across and see that point. So it's going to try to connect a little triangle edge here. Now, ask yourself, what's the elevation at this point? Let's assume this elevation is, let's call it 100. If I look across here and see this point at 100, it assumes that's flat across there. So it's going to make a flat triangle. Whereas if this is 100 and this is sitting down at 95, if I have a triangle that goes from here to this contour line, then that would be relatively valid. It would be 97 and a half, halfway in between those 2 points. That would be okay. But what is the true elevation right here where my cursor is sitting? If the triangle forms across there and it says it's 100 all the way across dead flat, that's not exactly the right elevation, is it? If you look at it between these 2 contour lines, it really should be about halfway in between there, about 97 and a half. So the edge from here to here should really come down here and hit a low spot and climb back up to hit it on the other side. But I don't have that line in between here to keep that edge from forming. If I did, then it could come down and find that line. It had a point in it, and it would read the elevation of that line that is descending in elevation as it goes down those contours. Same thing would happen in here. I could look across and see this triangle that could form from here down to here would be correct. But if it looks across and sees this point, that would not be correct, nor would this one, nor would one from here to here. That would make these into flat triangles. Okay, so keep that term in mind when we talk a little bit later. We'll learn how to deal with those. Okay. So right now, if I were to try to recreate this surface from just my contours, I'm going to get all kinds of errors in there. There's another place in this data set right up in here where the contours are just broken up because there's a retaining wall right there. It's actually the edge of a loading dock. But there's no line work in between there to keep that from, excuse me, from happening. So I can be sitting on these points, and that is at elevation of 1319. And it would allow me to look down here and connect directly to these points that are at, say, there's 1309. So that's a 10-foot drop. And then there's, let's see, this one here is still 1319. And out here, it's 1312, 1311, 1310, 1309, 1308. And even out to here, 1307. So it could connect triangle edges from 1319 all the way down here to 1307 in a straight line. It's going to make sort of like a ski jump, a ski ramp or something through there. Unless I have these lines drawn in that keep that from happening. Now I'm going to go back to my plan view. So I'm going to click on my top of my cube over here, or you can type the word plan and hit enter, and then hit enter again to confirm. And so now let's look at what we see in that area. There's that retaining wall. They've drawn it in, but right now it's just a 2D polyline at 0 elevation, so it would not be used. But remember all those white lines that we froze just a minute ago? Let's turn them back on. Let's go to the view menu. And instead of their freeze layer, let's choose thaw layer. So now they're going to come on. And so now, if I hold the shift key and press on the wheel of the mouse, I can spin this up and say, oh, look, there, they've got that drawn in. And in fact, if I look at that, you see that? That shows the top of the wall and the bottom of the wall. And over here in my road, where I typically had some problems, I'm going to have these road edges that are going to walk right down the nose of those contour lines and define the edge. So if I look then at these contour lines to start to form triangles, when I'm sitting at one of these vertex points here, I can't look across and find a point on the same contour line because there's a line in between it that's already drawn. That's my break line. Okay, so that's going to, here's maybe a better place to illustrate it is right here. This point can't look across and see this point. It can only see points along this line and this line and this line, just anything that doesn't have anything in between. So those break lines are pretty vitally important. Now,
Could I just interrupt you for a second?
yes, certainly.
How do you default back to the regular plan view once you've shifted it that way?
Do you have this little icon in the upper right corner?
Yeah. So hit top.
Yeah, you can do that. You can also type the word plan down at the,
Yeah, I did that and it didn't do anything.
all right, so if I type plan, right, and then hit enter, it's going to ask me one more thing, plan
Yeah,
of what, and I'm going to use my current UCS, which happens to be the world. So I hit enter one more
just
time.
hit enter. Yep,
Okay.
got it. Yep, and then one more really fundamental question. How do I dock the properties
Oh, okay.
bar menu?
Um, if you have your properties undocked and it's
Yep,
floating like this,
I don't even see them.
okay, so if you don't see them, I'll go ahead and turn it completely off. All right, my properties are not there. If I want to look at the properties of that selected item, I don't see it anywhere. So I have to right click and choose properties.
Yeah.
Okay. Once that's there, that's going to pop my properties palette up. Now, if
Yeah.
I just grab, and the title bar of this palette is actually vertical, it's on the left edge. So if I grab it there and then slide it over, it's going to pop into place like that. Okay.
Okay.
So it
Yeah,
becomes
mine actually just did that as soon as I hit properties.
now there's one other setting that you need to sort of maybe be aware of on these, any of these palettes that you have open. You can have tool palettes and other things open. When you have them out here floating, there's these two little icons, one of which says auto hide, and one it has a little menu on it. And you can also right click it and get the menu. So the menu would allow you to allow docking.
Okay.
Okay,
Yep.
so that has to be allowed before it will dock. You can give it a certain transparency, because some people actually just let them float on the drawing. So you see how you can see through it a little bit there.
Yeah.
All right, so I'm going to put my transparency back to solid. Um, and one of the other things is this auto hide. So auto hide, and even if I dock it, auto hide is going to do this. Did I set it to auto?
Yeah, I've had mine that way on my work
Yeah, so auto,
laptop in Carlson too, so
if I say
but that's
auto
good to know
hide,
it's that easy to
yeah, it
shift.
collapses down. So if I want to see the properties, I'll select something and I have to hover the mouse over it to get it to
Yeah.
fly. I hover back away from it and it hides. Now I have in other configurations, I have, um, I have some palettes like, excuse me, like my X reference palettes. And I don't know. Yeah, it's not a palette in IntelliCAD. In AutoCAD it is. Also, this layer manager that you see, this is a palette in AutoCAD. It can also be docked. Um, so I keep my layers palette open and docked, but I have it set to auto hide. And if I want to work on layers, I just hover over and it pops up. I work on it, hover off, and it closes back down. My
Oh, how
prop,
do you get to that palette again?
well, you don't have it in IntelliCAD. In
Oh, okay. Okay.
IntelliCAD, it is an actual, uh, it's a window itself. See, it's not a dockable palette. I don't,
Got it.
well, you can dock it as a
I feel
window.
like okay. Maybe I'm confused. I feel like I've
Well, if you're running it in AutoCAD, it would be a palette like this is here. It's just a different
okay.
presentation of it. There's
Thank
another
you.
palette. Let me see. Let me show you how this might work. Tool palettes. Okay, so here's a set of tools, and it's got a bunch of different commands and things that you can drag and drop into your drawing. And it's a palette. Okay. Now it can stay over here and stay docked, or it can also be auto hide. Okay, so then you pop it up and go away from it. It gets out of your way if you don't need it, but if you do need it, you work on it here and choose different categories and then go away from it. Okay. I don't generally use those tools, so I don't have that palette up. But that's, yeah, good question. If you're not seeing those, now I leave my properties not set to auto hide because I don't want to have to select something and check a property. I have to keep moving back and forth. So I leave it there so I can see it all the time. Okay, there are, AutoCAD also gives you what's called a mini properties. If you just hover the mouse, a little mini palette pops up at the cursor and tells you things like the layer it's on and what it is and some relevant information. It's not as extensive as properties. All right. So good question there. Now, what we were talking about using these break lines as our data. So if I try to model this data, I'm going to get some potential errors because these white break lines, which are good to control to keep these contours from looking across and seeing each other, but they also cross where these contour lines are used. And the contour lines themselves are considered break lines. It's just line work. And so those are considered break lines as well. So they're going to keep points over here from looking across the contour lines and seeing points over here. All right, so that's okay, except and you got to realize is that these contours are generated. They're not drawn. They're generated from looking at just these 3D lines, these break lines. And so the triangles that form are going to form between these vertices. And of course, these points on this line can't look past this line and see points over here on this line. So they can only go down to those points that they can see and no further. The same thing, these points can't look across, so it has to stop at those break lines. Now, when it forms a triangle, like say from this point to this point, if I look at that, I'm hovering right there in the grip, and I'm going to look down here at my status bar, my contours. I see that as an elevation of 1307.64. So it may have formed a triangle edge from 1307.64 this direction down to here that is sitting at 1304.28. So where do the contours cross between that? If that's 13.04 going up to 07, then 1305 is just pretend you're along that line. So 1305, 1306, 1307, 1307.6. So what happens in the triangulation process is it builds these triangles from just these white lines, and then it figures out along each of those edges where those even elevations are, and it connects all of those up together, and it results in a contour line where you've connected all those points of that same elevation. Okay, so we would not, and they did not read the contour lines to make the surface. The contour lines, therefore, were not an input into the process of making the surface. They are actually an output of the surface. So the surface got made, and then it generated the contour lines. So we need to quit thinking of contours as defining a surface and thinking of it more like the contours are simply representing the surface. Because, again, if you look at these potential triangle edges, say this one across to this one, right here from that point to that point, I've decided that, all right, there's my 05, 06, 07. That's a 1 foot contour interval. What if I had a half a foot contour interval? I would find 04.5, 05, 05.5, 06, 06.5, 07, 07.5, 07.6. Or I could have a 2 foot interval. So I would I would not see this contour. I would just see this one at 1306. It doesn't quite get up to 1308 yet until it gets all the way over to here. So the contour interval is even something I can choose, and the surface will kick out those contours at any given interval that I want, as long as I built the surface. Okay. So I'm sort of kind of prefacing all of this to get you to understand that if you use contours that have already been created and try to build a surface from the contours, that is like taking a photocopy of a photocopy, and you keep losing information, and then you're left with assuming just straight line linearity between the contour lines, and you don't have the information in between like you do if you take it from the break lines. Okay, so this company, T3 Global, knows that when they deliver this file, they're going to also deliver all of these break lines that they compiled in their photogrammetric instruments to whoever is using this data set. In fact, this was done for the Pennsylvania Turnpike Commission. So they deliver that to them so that they can then build their surface by using that break line data. If you don't do that and only deliver the contour lines, like we saw when we had these frozen off, if that's all we deliver, that's all they can go on. And they would either have to recognize that they need to put this line down these contour nose locations and raise them up at the right elevations, and find places like over here at this break, at this wall, and they would have to know that they'd have to create all of that themselves first. Or what usually happens, they don't realize that and they just build a surface from the contours, and even though it gave them no errors, the surface is incorrect. Okay. And you can see another case right in here where I've got a little discontinuity in that contour line to that contour line because that's stepping up this this little I don't know what that is, some kind of a wall of some kind. It's it says V-site structure. So, but now it's not elevated, it's not drawn there. But if I were to turn my brake lines back on, I would see that show up, and that's what caused that to break. So in reality, this contour line comes up here, hits the top edge of that, and then walks down the face of it and comes back out down here. Okay. And you're familiar with that process in terms of, you know, like going across a curb, like there's 1307. And this one is 1307. So it comes here and then it goes across here, and either straight across and down the face, or straight down this face and across. We don't really know. They've just trimmed out the edges there just to indicate that there's a structure there in between. Okay. So we have a bunch of information here. And again, and sometimes you have this, sometimes this is all you have to work with. You don't get those break lines. All you get are the contour lines, and you would build a surface from the contour lines and say, yay, yippee, I'm done. So we're going to do a number of different methods here and look at our 3D viewer and learn to use that and to evaluate it, and then see what are our best options to create these surfaces. Okay. So there also happens to be in this file that you're looking at, you can't see them because they're really just little tiny dots, but I'm going to click down here and I'm going to draw a window up here, and you see all these little grips that show up. Those are all my properties. I've selected 25 points. I've got points in here as well. And so those are points, those are CAD points. And remember, I'm going to go to my settings menu, come to my IntelliCAD settings. I'm going to choose point style. And I'm going to, instead of using that dot, I'm going to switch it to use this X. And I'm going to make my point size, say 2 feet, and say, okay. Now you can see all those points. So what the aerial mapping company actually did is they created, and I'm going to go back to view and thaw, or yeah, thaw my layers that I froze. And then I'm going to go back to view, and I'm going to pick layers by pick, and I'm going to turn off these contours. I'm going to pick one of my obscured, one of my index, one of my obscured intermediates, and one of my regular intermediates.
Ken, I'm sorry, could you slow down for a second? So under settings, it's the Carlson configure?
No, all the way down at the bottom in IntelliCAD settings.
Okay, yep,
Yep. And then choose point style.
got it.
And then I set that to I chose that X
Yep.
and I set the size up to 2 so you can see them a little better. Now, this is what the mapping company, looking at their three-dimensional stereo image in their instruments and their stereo compilers, and they have a little dot that they raise up and down and they float and they look to see where it hits right on the ground. And so they go through and they you can see these points are all sort of regularly spaced, usually on about um, a 10-meter spacing or whatever they happens to be. And they just very rapidly go here and drop a point, drop a point, drop a point, drop a point, and it reads and registers that elevation location. And you see if I select that one, I see it has an elevation of 1316. And then over here's one that has an elevation of 1317.06. So it puts all of these down at their right elevations, and they've taken a few of them, like this one here, and labeled them as just part of the um, part of the presentation of their mapping. But all of these points are actually part of the data. We didn't really see them because they were just little tiny dots. And they also went and recognized, hey, there's an edge of a pavement over here, wherever that is, like right in here. See, there's my inlet, there's my inlet over here. And so they put that little floating dot in their model right down on the edge of that pavement, and they walk it right down that pavement edge in the 3D model, and they raise it up and down to make sure when it coincides with what they see as the ground elevation, they register another point. So they would, in this particular instance, they would have raised it up and down, hit the ground, click. They're continuing to draw a line. They raise it up and down here and they go click, then click, then click. And so they get them at key points that they can recognize as all of those actual places where the elevation changes. And again, they do this very fast. It's not a inherently easy thing to do. I mean, we had to study doing this in school, and it was the hardest thing in the world for me to be able to see 3D. So that's one of the requirements working for these firms. Jack, you may be able to confirm that issue. You got to be able to visualize that in 3D. Now, you're going to have the advantage of using point clouds where you're going to have just millions and millions of points, and they're going to represent things a lot more densely. But in this case, they're looking at a photographic stereo image. Like, remember the old GAF Viewmaster things where you look at the Flintstones and they look like they're 3D because one eye is looking at the image and the other eye is looking at that same image, but imaged from a slightly different angle. And so your brain puts those together as if you're looking at them in stereo. That's what these instruments do. And they very quickly, like they could probably put all of this data together. I'm going to say maybe it might take them a day. Um, Certainly no more than 2 days, but probably even half a day because these guys are really good and they're really fast that do this kind of work. And so they generate all of these lines in 3D as they're doing that model, and they drop points out here in the open space where there weren't really any edges, but they just densified all of this information here. And it's just as if you had walked the ground with a level rod or a total station or a GPS receiver, and you just recorded all of these points, and then all of these points you recorded, but you connected them together because they were along an edge, like the edge of the pavement, the edge of a curb, like up in here, you see these curbs. Okay, and so that's what they then used to generate all the surface triangles, and then they let the computer read those triangles and decide where the contour lines cross. And so that's the output of that triangulation are those contour lines. Okay, this is the input, the break lines and the points, and it generated the contours. Now, sometimes we have, and I'm going to go back and reset these points here for a minute. I go back to my settings menu, all the way down to the bottom in telecad settings. And I'm going to choose point style. And I'm going to select the little dot, this second one down, and say, okay, now that's back to the way I had it before, and I don't really see them unless I can look really close, or if I select them, I can see them. All right, so they are there. I'm going to freeze. Well, let me see. I'm going to, yeah, so I'll leave this like this. So this might represent what I want to look like that I want to go and model my surface from. And I may at first glance look at this and not recognize any points in here. And in fact, if I do the 3D trick here by holding the shift key and pushing up with my cursor, I still don't really see them unless I can get in tight and turn on this point styles. But which I don't generally change that point style to be able to see them in general. And here's the reason why, because instead of doing it this way, let me go back to my plan view. I'm going to use Carlson's 3D viewer. Now notice the difference here. So all I did, if you're not to this point, I'm going to reset the stage. I'm going to turn everything back on. Okay. So let's go to the view menu and let's choose freeze layer by pick. And notice it has a little icon that shows the freeze symbol on a layer, a picture of a layer, and a little arrow indicating that you're going to pick it. Otherwise, you can freeze layer by selection. And all you're doing is either picking, which freezes it immediately, or you can build a selection set and then hit enter, and it takes a look at the layers that the things you select are on, and it freezes the entire layer. So you don't have to select everything. So I'm just going to choose freeze layer by pick. And I'm going to come in here, I'm going to freeze my contours out of the way. So I'm going to click on one of those index contours. So it immediately froze. I'll click on the label to get it out of the way. And then I'm going to click on one of the intermediate contours. Now they're gone, except you still see some here. And they are on a separate set of layers because you see that word there that says obscured. That means there's tree cover over it, and they're not really certain about what's inside of that tree cover. Same thing over here. You see I'm inside this tree line. They've sort of seen it, and they can sort of guesstimate how it works around the edges. But because it's under tree cover, they're telling you that these contours might not be exactly right. But I'm still in my command to freeze pick or freeze by pick. So I want to make sure I pick one of these contour lines. There's the index ones, and I'll pick another one of the intermediates. And now I'm back to where I was looking here before. Okay. Now, again, remember we have been looking at this in 3D just in the CAD viewer by holding the shift key, pressing and holding the wheel on the mouse and pushing it up. And you can see now here's something else that they did was they took all of these brake lines, and some of which are out in the middle of the field and they don't correspond to anything, like these that come around the pond edges and the ones that run down the pavement and all of that. But the ones that are recognizable features that you want to map, they also copied them down to 0 elevations and drew them in for us. So there's a nice crisp curb line. There's my edges of pavement, or that's the edge of the island out here. So it's asphalt up to there and then curbs. So they have, I think those are actually painted stripes probably. So all of these lines that they did on the ground, the ones that corresponded to actual visible edges, they also copied down to 0. So I've got them there for my mapping purposes. If I were to go back in plan view and turn off the white lines, I would see the ones that they copied down to 0. You see they're right directly underneath each other, okay? So instead of doing this here and having to remember to check with that point mode, changing it to an X, a 2-foot size, and switching it back, it's easier for me to, because I've learned how to use the Carlson 3D viewer, and so that's what we're going to do next. I'll pop it up here, and then we're going to need to take our mid-morning break, so we'll come back after that and reset it. But I'm going to go to my view menu, 3D view, and my drawing viewer, not the surface file, but the drawing viewer. It prompts me to select entities, so I'll do that. Got everything selected. I'll hit enter to finish. I'm through selecting, so I'll hit enter. And now it's going to pop up into this viewer. Now yours might be, floating like this. It's, you can maximize it if you want. I usually like to do that. And now look at the difference. Up here, I've got checked on to ignore zeros. Now you see the zeros, they're not directly underneath it here because I'm looking at it in a perspective view, which I'll turn this on and show you. See, there's that perspective, and it looks like, it looks like that. So it is directly underneath it, but when I'm looking at it in plain view, in this viewer, I'm in perspective. So I'm going to uncheck up here on my view control. I'm going to check that box to ignore 0. I'll go back to settings and turn this box off for now. We'll learn about those things as we go along. Now, what do you notice different from this view versus, now you don't need to exit, but I will, but or let me just do it this way. What do you notice different about this view compared to this view? I get things like my words, like these pink labels that you see out here, these red canopy things, I think it's called. They're the canopies. I've got some other things like those inlets, things like that. They don't show up because I have told it to ignore zeros. But what else do we see immediately recognizable? You see these points? They're now visible. So I can look at that and immediately know that, hey, this drawing contains a bunch of points. I just selected a bunch of points along with those 3D break lines. That's the data that I'm going to use to model my surface from. And I didn't have to go back to my drawing out to this part and turn that point style on. This viewer reads the points and makes them big enough for you to see. So that's one advantage. Now, let's learn how we can look at this stuff in 3D to use it to help verify our information. And we're going to learn about all that as we after we come back from our break here. And it's going to be learning how to, spin this stuff up, turn it around, look at certain features in our data set, how to orient ourselves like this. How, if we don't want to see our points anymore, we can even go to our model over here, find the layer that's on, and which would be these, you see they're turning on and off. So you can control the visibility. You can even change the visible color that you see here based on those layers. There's all kinds of controls that you can use. So we'll learn all of the, or we'll learn the important ones of this viewer, and will very quickly in your work, you're going to, I hope, you're going to start to see those things, and you'll start to use these tools without even thinking about them. Right now, I recognize they're probably pretty foreign to you, but that's part of what we're going to learn to use. And this is a tremendous tool to help us evaluate things and evaluate problems. Okay. So we'll pick that up after our break. I'll go ahead and exit that, and I'll come out here and I'll save my file. So you should have it looking like that. And we'll come back there. We'll take our 15-minute break. Let's come back at 5 till. So that'll give us some 14 minutes. So that'll give us a break, and then we'll pick up and go to lunch. Now, today for lunch, by the way, folks, I need to make sure we break for lunch exactly at my 12 o'clock. I've got a conference call I've got to jump on for another project. It's the only day they could do it. So we'll try to stick to that schedule. So, all right. Any questions at this point? Everything good? All right. So I will pause the record Zoom. I had neglected that. Sorry about that. So we've missed a little bit of that discussion. Haven't really got into the Carlson side yet. But anyway, so if we want to try to find a command, I learned this from a class just earlier in this week. I'd never actually looked at this command, but it is so useful. It's so good to point out. And it's a command called command search, and you could type it at the command line, or it's on the help menu. And it's right here called command search. Okay, now I also have out here, I've got my help toolbar out, and it's that icon that shows a pair of specs on it, and that's going to be searching for a command. So now here you can see these are all the different commands that you could issue, and these are Carlson commands. I think there's also some CAD commands there, but if you're looking for something, let's say I want to know how to turn my cube on or off. If I type cube, it's going to close this down and tell us what these things are. So, so I see now that doesn't have, see, that doesn't have the IntelliCAD cube version of that. But let's say we've also got another command. I'm going to exit this for just a second. I'm going to show you a very useful command that I do all the time. And it's called edit. It's on Polyline Utilities. And I'm going to come down here where it says remove polyline. And that doesn't mean erase the polyline. That means it's a pull right menu, and these are remove functions. And one that I do quite often is to remove a polyline vertex, because it's very fast and it lets me just click near the vertex I want to get rid of. I do that command quite often. And here's what I used to tell people to help you learn where these commands are. You figure out where they are on the menu, and then you can look down on the status bar down below here, and it tells you a little synopsis of what the command does. Now, this is not universal. It doesn't do it for all commands, but most of them it does. It tells you what it does, and then it puts a colon down, and it shows you what the typed command name is. But then I would also say, well, anytime you see a command on a menu that maybe you use a lot and you don't want to click, 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 click your way into it, if you look and see that there is an icon for that command, that tells you, first of all, that it is on a toolbar somewhere. Doesn't tell you which toolbar it's on. Okay, so I would say, well, it's a polyline function. Maybe I'll turn on my polyline toolbars and I'll see if that icon is there. And I do look at it up here in my polyline toolbar, which is this one here. And I see there's that icon. There's a pencil eraser right over top of a polyline with a red vertex. Similar, there's the same pencil eraser over the polyline, but it has a red segment. So that's that corresponding command. All right, so that was sort of a roundabout way of doing it. I didn't really know much about how to tell people which toolbar it's on, other than just try to, guess and figure out if it makes sense. One that we do a lot, for instance, is view, freeze layer by pick, and isolate layers. We do a lot of stuff here. I'm showing you from the menus, but all of these have icons, and you see those same icons up here on my layer toolbar. Okay. There's also one there called Erase by Layer, and that's up here under Edit, Erase. And there's that Erase by Layer. Again, there's the icon. The thing down at the bottom of the status bar says that it erases objects from the layer based on the layer name. The typed command is LDEL. I see an icon, so I know it's on a toolbar, but I might not know that it's on the layers toolbar. I might think it's on an edit toolbar of some kind. So that doesn't help me a whole lot. So here's the beauty of this command on the help menu called command search. So this is going to pop this up, and you're going to just type, let's say that was remove polyline vertex, but let's say maybe we just said remove. And so it's going to limit it to all the commands that talk about removing something. And so here I look down here, oh, there's remove polyline vertex right there. All right, now look what else it tells you. It tells you which main menu it's on. So that is the first menu you go to would be edit. And it's on a sub menu, and it's under remove polylines, and it's a pull right from that menu. Okay. Which modules have that command? All the modules have that command. Now down here's one sentence that says remove lot edge. Well, only survey and civil have that command. So back to remove polyline vertex, that tells you the modules. That tells you in this column, if you're a typist and you like to type your commands, you can type that and that would issue the command. And then over here is that lovely little missing column that tells you it is on a toolbar, and if it's blank, it's not, but if it's got something filled out, it tells you which toolbar that it's on. There's one, for instance, remove spaces from text. If I did that all the time, I would look for that toolbar. It's the text, and when it says Carlson, that means you would load up that toolbar. Under the Carlson, because there's also a text toolbar under IntelliCAD. So it's telling you it's on the Carlson text toolbar. And if you find yourself using a lot of these a lot, you might want to have those toolbars out and available once you learn where those commands are. Okay. The other thing you can do from these is when you select that command, there's that remove polyline vertex. I'll go back to that one. Is I can hit the help button and it takes me right to that portion of the help system. Or I can also choose the run button and it executes it right there. And it asks me to now select the polyline I want to remove from. So if I select this polyline, it shows me all the grips of all the points, and I can just go through here and click, click, click. And the nearest place, I don't have to snap, just the nearest places I click to is going to be what gets deleted out of the command. Hit enter to end, which I just did. Okay, so that is a really great little tool. Now, if I look for that again under help, command, search, you notice there's nothing about that view cube. I just type to view, and here's my 3D viewer, my drawing viewer, surface viewer. I don't see anything about my, that would turn on that view cube. Okay, because it's not a Carlson command, it's an IntelliCAD command. And I'm trying to see if maybe they also have it. Maybe if I say view cube, nope, nothing with that, even with cube. Or if I said navigate, let's try nav. See, nothing. So it doesn't work for IntelliCAD only commands, only the Carlson commands, but it's a great little way to locate which menus they're on, what the keyboard command is and what the toolbars are. Now, those keyboard commands, for instance, if I see a command, let's go back to that remove polyline vertex. So I see the keyboard command is RMVERTEX. Well, I say, well, gosh, that's too much to type all the time. So you have another thing under your settings called quick keys. And I'll leave this to your own discovery with the help system and stuff. But basically, you can type in a quick key, and I think I may have already done it. Yeah, right here. I've made one called RV, and it runs this command called RMVERTEX. Now I have to put it in parentheses with a C colon because it is an auto Lisp command. It's not, that doesn't mean drive C, that means it's a command. And so that's the way it works. Some of these commands you issue with an underbar and a dot. Some you issue with a parentheses and a C colon, and some are just the individual commands. There's no real way to know when and where you have to do that, but I would try, if you're going to try to a command, you don't see it here yet, you're building a new quick key, then when you're building it, test it. If it doesn't work, switch it to one of these other formats. Okay, so now I've got one called RV, and if I just type RV at the command line and hit enter, it runs that command, select the polyline to remove from, okay? I'll press escape. So those are a couple little things that should be able to help you learn the commands and where they are, okay? Now, let's go back to our Carlson 3D viewer and let's learn our way around some of the tools inside of it. So this is view, 3D view, drawing viewer. Now there's that icon. It's on a toolbar somewhere. And that toolbar that it's on happens to be this one up here, which is my surface toolbar. Okay. That's called view. The command is actually called cube. So again, from my command search, if I just type cube, got a number of things. So here's my drawing viewer. It's on view, submenu 3D view. All modules have it. There's my command. And here are the toolbars that it's on. It's on Takeoff General, and it's also on the Carlson Surface toolbar. So that's the one I have showing up here, and you see that little icon show up. The same thing is my Surface File Viewer, which is basically the same thing, but it asks me to pick a surface file that I've already built and loads it up into the viewer instead of things from the drawing. So that's the two differences here. The drawing and surface file viewers, it's really the same viewer. It's just what it puts in the viewer. It's again, that surface toolbar has some nice little things, one of which is those two views that I see up here. So this, choosing that icon is going to be equivalent to going to view, 3D view, drawing viewer. So we're going to do that. We're going to select all of our objects, hit enter to finish selection. And we're now in the Carlson viewer. You can see your points now. We have the main view window, and we have three different tabs up here at the top. And you can see, like under the model tab, this lets you control the visibility of certain layers. If you have a surface loaded, you can control color and transparency and turn them on and off, different things. But let's start simple. So the first thing on our view control tab that you see is whether or not you want to ignore 0 elevation entities. We normally leave that on because we're only interested in looking at things that have 3D. So if we don't see something here that we thought was elevated out in the main drawing, you would know that it's not. You could toggle it on to see. And again, remember, you're in a perspective view. So that just toggles the visibility of those. color by elevation is something you won't see it show up much here. If I say all, it's still going to change color based on low colors are blue, mids are green, or low elevations are blue, mids are green, highs are red. So that lets us see a couple of areas here just by this little color spectrum. I'm going to turn that back off and I'll go back to the color or that the objects have out in the drawing. Okay. Now the next one is this bit here, a sky view. Let's turn the moon on. Requires hardware accelerated. Um, which I can't really do, but it puts a little cutesy little visual background here. It really does nothing more than make it look more like a video game type of thing. So it doesn't do much for us. But the next one that we would pay attention to is this vertical exaggeration, the vertical scale. So it's not going to change anything. It's just going to show us the scale. So right now it's set to 1, which is what we would normally keep it to. But if I said, if it's a very flat terrain and I wanted to make sure I picked up some things, I may bump this up. Let's go to a 10-time vertical exaggeration. And now you can see how it's really exaggerated that. Maybe I'll put it back down to 5. So it's exaggerated the vertical differences. And so if I put it back to 1, that's now what I'm going to look at. Now, how am I spinning this around? This is the key thing. We'll talk about the rest of these things when we look mostly at the surface stuff. This is controlling our light. Any of these icons with the magnifying glasses, your wheel on your mouse, zooming in and out, press and hold it to pan, just like you do in the CAD file out in the CAD window. That works the same. You don't really need to worry about that. Same as the pan handle there. The key ones that we want to look at of these buttons are this one with the 3-colored cube and the rotation arrows around the base. That's our main viewing control tool. That'd be the one we use. These remaining ones down here this is a toggle. You see my little pop-up, it says toggle the shading of surfaces. Now I don't have any surfaces in here. These are just lines and points. If I had 3D faces, or if I loaded up a surface file, that's going to toggle on, it's going to basically fill in the triangles with a solid color. And it's a toggle. You just turn them on, turn them off. The pointer button is once you have things situated like you like it and you go and you want to look at something in particular, let's say this particular edge here, if you point to it, you see the little status line down here at the bottom. It's telling you what it is. It's a polyline. It's on a layer called V-topo break line. It has an elevation range from here to there. And the elevation at where I'm pointing is 1299.39. If I go to a different location, it will give me a different number there. Okay, so tells you the length of that segment. And if you should double click that feature, it gives you an option that you can actually change the layer. You can set it to 0, excuse me, or you can add it to a selection set. So once you exit the viewer and go back to the CAD system, it's now part of that selection set that you can do something with it. Okay. The other version, the other buttons, let's say I did have something, say rotated up and I've zoomed in down here. Now I've got 2 of these and they're both for plan view. The next to last one says resets the view to plan view. So if I click that, it puts me in plan view, but at that same height up in the air that I was. If I click this one, it does plan view, but zooms out to show you all of it. That's a zoom extents. Okay. These other buttons here control the rotation about the axes. And right now, there's my X slider. My Y slider, notice, is gray. I can't move it because I've got it locked. Okay. If I unlock it and move it, you see it rotates about the Y axis. I'll put it back into plan view, and I'm going to keep that locked. That's important. The Z axis then, of course, rotates it about the Z axis. So you could do everything with the sliders. Then you have some directional views, like from the northeast, from back to plan view, different kinds of things here. These buttons below, you can save what you're looking at to an image file. So it make you a JPEG or a PNG. You can print it. In this case, let's see, save to a PDF file, make it into a 3D PDF file. There's your help system, and then there's your exit button, same as your big X up in the top right corner. All right, so how do we control this view? Using our icon. So we're going to come over here and we're going to make sure we select the icon that shows the 3D cube, and it shows the rotation arrow underneath it. Again, that's our main control. Now then just hover the mouse over the drawing part, and you notice right now it looks like a Z with a little rotation arrow around the Z because I'm off to the edges. When I get over the bulk of the drawing, now notice it's not exact. You see, it's probably, if I were to, let's see if I do, yeah, it's not even exact with the base. But it works like this. When you are on the outside edges, it's going to be a Z shape. When you are into the data, and again, it's not exact. You see, it doesn't flip on and off right at the edge. It just sort of has to be in the bulk of the data. It's going to switch to an X and Y only button. So that means if you click and hold the left mouse button, click and hold it, and then push it either up and down. And again, you'd see the slider over on the right, that's rotating around the X axis. If I were to go left and right, it's trying to rotate around the Y axis, but I have it locked. So if that were unlocked, I can go up and down, left and right as I rotate that around in those fashions, okay? And if I put it down here on the edges, it's going to, let me say, we'll put it up at a certain placement like this. And then if I go to the edges to where it turns into a Z shape, press and hold, it rotates it all around the Z axis. And it does it from any of the edges. It doesn't matter where. All right, so I'm going to go back to my Plan View Zoom Extents button. I'm going to click that. Make sure my cursor is showing X, Y, and Z for different characterizations, let me say. So I hit the Plan View and then Zoom Extents. Now I'm going to lock this Y axis, and I'm going to tell you that this is going to help your control. Always keep that Y axis locked, and then you can forget about these sliders, okay? So we're going to make sure we have our controlling icon. We're going to position this to where it has our X and Y shape. And what you're going to do, if you want to look at a particular feature, let's suppose I want to look right along the edge of this raised island up here, okay? I want to basically stand over here and look at that, but I want to raise it up into 3D. Let's say that's my goal. So what I do is I zoom out enough to where I can see everything, and I'm going to visualize myself standing in my driveway, and I'm looking at my garage door. So all this data is my garage door. And I want to put the mouse down toward the bottom, make sure it doesn't switch to Z, make sure you're still in the XY shape, and you want to click and hold the left button, and you want to raise your garage door up. And if you have to go back and get another bite of it, let the mouse button up and go back and grab it. And you want to roll it up, not too far, not all the way flat, but you want it to sort of be almost raised up. Okay. Now you've got it at an oblique angle. Let the mouse button up and now go down to the bottom. You could do it on the sides either way, but the bottom is generally, and you want to spin it around the Z axis. So I'm going to spin it around until I'm looking right there at that area I want to be looking at. And now I might want to, reset that a little bit, just tweak the placement. And then I'm just going to I'm going to point to where I want to look, and I'm going to use the wheel to zoom in and out is what I'm looking at. So, and then I can press and hold the wheel, and I can pan. I can, use it to zoom, and I might, tweak my obliqueness a little bit here. And let's say now, instead of looking at that, I want to look up this little valley that fills that pond up. Well, I'm all whopperage. I don't know where I am. Just go back to the plan view, do your zoom extents. So now I want to line up and look right up this feature here where this pond comes in. So I'm going to raise up my garage door. I'll spin it around to where I'm looking in that little valley. I'll then point to it and zoom in, and, maybe under this pond, I want to look at some things. So that is the general. So if I want to look at that little retaining wall right in here, so that was generally what you do. You don't have to always reset it to plan view, but sometimes it's easier. So, but sometimes you just zoom out and reset to the, perspective that you want to be looking at, and then you zoom in to your area of interest. Okay, that's basically it on the viewable part. Now there's one other set of controls down here at the bottom, are these clippings. You've got clip near, clip far, clip top, clip bottom. So if I clip near and I'm in plan view, I'm going to take this and slide it, and I'm going to be very careful here at the edges. You see what it's doing is it's clipping away the things that are nearest to my eye. Well, I'm in plan view, so the clip near is going to work exactly like clip top. So if I slide that over here, well, you're supposed to. If I clip the top, that's not working in plan view. All right. So if I do it up here, let's say I want to look at this pond feature, but this stuff here is in my way. So I could then clip the front, clip my near, and it's going to clear out, the things I don't want to see. And it just works by clipping off the things that are nearest to me. If I now do my clip top, it should, for some reason that's not, there we go. So that is not the same as clipping near, it's actually clipping the top from the elevation perspective. Right. There's something about this particular set of data that's not. If I clip it from the bottom, maybe I have to be looking. Yeah, I guess I have to do that. So it's actually clipping it from the elevation. It's taking that elevation and basically slicing down in. So you notice this slice edge is not straight. It's just clipping it from the top down. Okay, so you have to be, I think that clip near doesn't work. I mean, the clip top doesn't work if you're zoomed way out. clip near does. But anyway, those are just some things that'll help you fine tune what it is you're looking at. So if I'm looking, you know, right in here and I want to maybe shave off the top. Oh, that's still working like. No, it's following the, see right in here, it's clipping the high stuff and leaving the lower stuff, as opposed to clipping the front, which is just going to slide it. Well, it's actually looking at the same thing. So anyway, those are things that can help you visualize that. Go back to plan, do my zoom extents. And that's all on my view control tab. Your settings tab has all of these other things you can do. And you can show an icon down there so you can see if you're rotated, you know, if that's helpful for you. You can display an orbit, which, you know, I don't know what that does for you, if anything else. If you're looking at a surface file, you can smooth it, you can display the triangles, you can display the names, you can display, for instance, one that we do a lot if we're using, if you don't see it here because we didn't load up a surface file, but if you did, you would see display contours. And then you've got settings where you can set the contour interval. You can set, you know, thickness. If your lines are too skinny, you can make your line work heavier. Okay, so maybe put that, you know, leave that, I'll leave it at 2 so you can see it better. And now our point size, maybe they're still too small. We want to see them be a little bigger. All right, so that shows me all those points. All right, so these are things that are going to control some of the aspects of it. You've got some set colors where you can set high elevations, middle elevations, low elevations, set your contour colors, set your triangle edge colors. And here's our default surface colors. They can come in. None of these you really have to worry about, but you have the control over them. So if you're looking at view control, color by elevation, you say turn it all on. My colors go from lows are blue, mids are green, and reds are high. Then on my settings, if I set my colors to where I wanted my lows instead of being blue, or maybe instead of highs for red, maybe I'll make that you know, this white color. So see, the white doesn't really show up very well in contrast against the green, but you have control over that if you have a preference. I'm going to put that back to red. I just like to think of it like that. Okay, so these are different settings. Now, these two buttons here are, let's say I wanted to work on this area right here in my drawing, and I wanted to have my drawing rotated up to match this same orientation. So right over here, I've got these two different things. I can set my CAD view to match this view, because right now if I exit, it's going to go back to my previous CAD view. If I click that, it says, okay, I've now set the view. I don't see anything happening here yet, but when we come back out, you will. Here's another place where you can select a new viewpoint in a target position. So the viewpoint is where you are standing, where your eyeball is in space, and the target is what you're looking at. So you can change those. You can give it a name to save it, to restore it later. And you would pull that down and choose set and delete. These block model objects, completely disregard that has to do with the mining stuff. Okay, so we're going to see this shading of fronts, backs, and both for our surfaces that will apply. But the block model you can disregard. It has to do with their mining software. And then finally on the model tab, you've got, and we'll not take this exhaustively, but you can add a surface. You can go out and add additional things from the drawing. You see, add additional entities. You can then edit a particular item in our list. You can add text into this. You can then load up a saved model, or you can save this as a model that you can load later. But all of these different objects, you see I've got some points. I got the layers that those that might be on. I've got polylines. You see the polylines have some different layers, and I can control their visibility. I've got some text here. So that text right there is on, I go back to my view control. I'll point at that text and I see that that is not showing up. Yeah, so it doesn't recognize that text there as to what it is. But on my model in text, let's see, that would be a topo spot. So I can open that up and choose any individual one, or I can just double click it. Or sorry, let me see if I can right click it, and I can choose freeze the layer, or right click it and thaw the layer. You can edit the surface or the display properties. If I didn't want that text to be yellow, I could change it to cyan, and it would show up. If I did the right ones. Guess it's not really text. Let's see here. You can also show hide as opposed to right click freeze. Set my color. Oh, I know why. Because I'm showing color by elevation. So I say none, and now come back to this. Now I should be able to change that to some color. Yeah, apparently it's not working for my text. But for instance, my spots, which were, say, this layer list, I come down here and set that to be, all right, now they're magenta. Maybe I want to look at them. Is it they're blue and they're still not changing? Oh, there's the wrong layer. It's DTMP. There we go. Now if I change that, see how they change. If you, and it doesn't change them out in the CAD drawing, it's only in the viewer. So that's what this model tab is for, is to control what's in the viewer, how you see it. Okay, so now, let's say I wanted to be at this orientation. I've saved my CAD. I went to settings and I hit save the CAD view to match it. And then when I exit, I'm going to be in that same perspective. Now notice I'm way off the position I was in, but I'm at the right orientation. So you may have to, double click the mouse to do a zoom extents, and you can go in there and you can see that it is rotated into that same perspective. And then I can work on this, maybe move a vertex around and snap to something else in 3D. So that's a tool to help us there. Now I can just do the same thing up here in my cube, just hit my top and reset back to here. So that's the basics of that viewer. They will become second nature for you. So we'll get to that as we go along. And we're going to use that viewer extensively as we start to look at things. So now let's go to the view menu and let's say thaw on all layers. We've got everything on. And now we're going to go to the view menu and we're going to say freeze layer by selection. And so now instead of freeze by pick, I need to just select one. I'm going to select this guy here. So I've identified that layer. And I want to come down here and find one of these points, but I can't really see them, but I'm in selection. So if I just select there, it tells me that I've got 13 in my selection set. So I've found what I need. And now I'm going to hit enter, and it's going to turn everything off of those break lines and the points. And if I go to view and look at my layer control, I can see in my layers, if I sort by this title here, freeze thaw, click it again to change the order. Those are the two layers I just froze. V topo DTMP, those are the points. V topo break line, those are those white lines, those 3D break lines. Those are the ones I really are going to use to make the right surface. But what we're going to do with those two layers frozen is we're going to build a surface using just these contours. And again, if I look at this in my 3D viewer, so I'll choose my view 3D drawing viewer, and I'm going to verify that, okay, all I have are the contours, and I've got a few of those spot elevations on there as well. Okay, so they'll be used as part of my surface. All right, so we're going to build our surface using
Ken, sorry, which two layers did you just pick to
the
freeze?
layers that I froze were VTopo DTMP
Okay.
and VTopo BKLN.
DTMP. Okay, thanks.
Okay. Now I'm going to freeze one more. I'm going to freeze these spots right here to illustrate a point here. So I'm going to go back to my view menu, and I'm going to choose freeze layer by pick this time. And I'm going to pick on one of those spot elevations, and you should see all of those spot elevations go away. And now I can verify that the only thing in my 3D view that has elevation are these contour lines, because that's what a lot of people use to build a surface. And that's what a lot of trainers train their users to, hey, use these, build your surface, bing, bang, boom, you're done. And they never verify any of this stuff. Now, here's what I want to try to teach you in this process is how to evaluate that. Okay, so let's do the step to build our first surface. So let's go to the surface menu, and let's choose this big, wonderful, powerful command called triangulate and contour. Okay. Now inside of this, we have these 4 tabs. If you look at the selection tab, this allows you to filter out certain things, even if they're selected. But we're not going to filter any of those out. We're going to leave everything included. But here's something that's interesting about this. For instance, let's say our data set, we had several thousand points in a coordinate file, but we didn't want to necessarily draw locate points and draw them in the drawing and sort of hog up our drawing. But we could say, specify these options, and I want to you could check these on or off. These are the ones it would ignore, but make sure Carlson points is on. And then you could also say, read the points from a coordinate file. And you would choose files of these different formats. There's our Carlson coordinate file. That's our CRD file. So that would go out and open that coordinate file, read the points as if they were in the drawing. All right. But we're not going to do that. So I'm going to uncheck this box here. I want to make sure everything's grayed out. But that's just a use for that selection tab. And it's always a good thing the first time you're working on something to go back and look at that tab, make sure nothing is filtered, because it holds the settings from the last time you ran the command. So always sort of check that at least once. Now we've got these 3 tabs that are going to control what we do. The triangulate tab governs the behavior of what we select and how it builds the surface. Once it's built, as part of this command, you can have it also draw the resulting contours, and you specify the interval you want to draw. And then if you draw the contours, which is right here, this checkbox, if you choose to draw them, you can also choose to label them. Now, what we're going to do for right now, because we already have contours drawn, there's no real need for us to draw them. I'm going to go to my contour tab and turn that off. Now, this is also another function here, is if you save this as a file, you can always, after the fact, draw the contours and compare them against the ones that you see here. That they provided. The ones that we're going to use to read to build our surface file, which will be erroneous. So we're going to go to our triangulation tab, and the first thing we want to make sure to do is to write that triangulation file. So I'm going to turn that on, and I need to hit the select button to identify a file name. So I'm going to do that. I see at the top, I'm in my proper folder location. And I'm going to call this EG for existing ground dash CTRS only. Existing ground contours only. I'll save that. And now I could, as part of this, draw the triangulation lines or faces, slope arrows, and all kinds of stuff. I'm not going to do that. I'm also going to uncheck this inclusion exclusion areas because I haven't drawn a boundary around it yet. And I've got this shrink wrap perimeter reduction. Pull that down and make sure it says none. We'll talk about that in a minute. And erase previous contour entities. Leave that set to off for right now, because once we were satisfied with our contours, we don't want to run this command again and have it erase, all these previous ones. We'd have to redraw them. So now here's a big switch, ignore zero elevations. We set that in our default settings, and there it is turned on for us. And now these are some other little filters that you can specify only certain elevations. These edge lengths, those are these edge triangles, and you're going to see them form over in here. You can give them the exterior edges can have a maximum length, and if you gave that a certain length, it would get rid of the triangles of a certain length. So right now, set them up to 2000 so that we're not going to get rid of them, and we'll talk about some of this other stuff when we go back to modify this command. And everything else down here, we're going to leave unchecked. So I've got 2 checks on, write the file, ignore zeros. I've selected a file, and where it says shrink wrap perimeter reductions, I've said none, and I'm going to erase my previous contour entities by turning it off. Okay, that's all I need for right now. I'm going to say okay, and read the prompts. It says select the entities. Well, read the line above and select what it's asking you to select. Get in that habit, because some of those other options are going to ask us to select things first before we select the data. And so now what we're going to select is I'm going to just drag a window around everything. Now remember, the only thing that has elevation are the contours, so it's going to ignore all of those other things down at 0. So I've now finished my selecting. I hit enter to conclude. Off it goes, and you see a bunch of stuff happen, and it says writing the triangulation file, and it shows you the name. I've got a file called EG contours only. It's out there in my folder. So what do I do with that file? Well, I could use that, as my design base, for instance. And a lot of people will do this in training classes. They say, hey, congratulations, you just built your existing ground. Let's go on to the next step. But here's the step they forget, and this is what you need to know. It's vitally important. We need to look at that surface and make sure it did what we expected it to do. So let's go to our view menu and 3D view. And this time we're going to choose surface file viewer, not the drawing viewer. That's going to ask us to choose a surface file. Well, there it is. One we just built, we hit open, and up it comes. And it's either going to look like that, or it might look like that. and it might not have any contours displayed. If it should look like this little icon that looks like a colored in fishnet is what's going to color in those triangles for you. Okay. So now once that's in and on, this little thing here is going to come into play, this little yellow ball. And you can think about that. You can think of that as the sun up in the sky. You get down on the horizon, you know, the sun's setting, comes up here, it's directly overhead at high noon. And so we generally, as humans, have been conditioned to look at this as if it is in the upper left and cast shadows to the lower right. So that might, you know, you might see something like this where this now looks like it's depressed and our ponds looks like they're raised up. That's because we're so used to seeing our shadows cast down and to the right. So put that up in the upper left corner and generally leave it there and move it around if you need to make some adjustments. Now, what we're going to do, and I'm sorry, I'm going to have to cut us off here right at 12 for lunch. I've got a conference call I need to get to. But as you play around with this, zoom this thing up, and you're going to look at these areas right in here along the road edges. See how they're sort of stair-steppy looking? And then also look right in here where that retaining wall was, and there's that little ski jump ramp that got built. And I'll change my shadows, you can see. So play around with that, and you can see some of the things that we've done, and we'll come back and refine all of this after lunch, okay? So I'm sorry, I'm going to have to cut us off at this point. So I'm going to stop our recording, and let's go now back to our drawing. I'm going to turn it back on. I'm just, if you've already got yours set like this is fine. But just to show you what we did, I'm going to run this layer control, which is under view, layer control. And I'm going to look for, I'll just have my layers are listed alphabetically. And so I'm going to scroll down here and I'm going to find this layer called V Topo BKLN. And I'm going to freeze that layer by clicking the little picture of the sun in the column where it says freeze thaw. I'm going to click it till it turns into a snowflake, so it's frozen. I'm going to do the same thing for VTopo DTMP, and then the same thing for VTopo spot. So I'll just sit right here for the moment. And if you'll find these three layers, there's this one, and this one. You'll find each of those layers and click the sun icon, not the light bulb, but the sun. So you want to freeze the layer. Okay. So that should set you back, Scott, to where we were before. Let me. Okay, Jack, you said, no, he's not back. He says he's in Carlson 2022 and didn't have the option to write the file. Actually, he should have. Let's see here, Jack, you actually can write the file even in 2022. Once you're back, I'll step you through that. All right, so I don't recall if Jack had I think Jack did not have the microphone. He only had the what you call it, the chat window. So we'll leave that way for him. So if you'll just freeze those 3 layers, everything else is thawed.
Uh,
That,
Ken,
yeah.
I don't think he'll be able to see it once he joins. Once if he joins anything past or any chats that occurred like prior to him joining the meeting, I don't know if he'll be able to see it.
It should be. I'm able to find everything that we've seen
Oh, okay.
back in the morning, but if not, when he comes back, I'll try to catch it and talk him through that.
All right.
So now he has, hmm, yeah, he's doing the, okay, I'm trying to look at my notes. Will, you're the drone work in South Carolina, is that correct? Or
No,
no?
I'm doing survey work in
Okay,
New Hampshire.
yeah, okay. So Jack is he does mostly the drone modeling. Um, and he doesn't have actually Carlson survey. He's got the construction module, he's got takeoff. And so switching to that particular set of menus, he's got under his takeoff menu, he's got these make existing ground surface. And when you do that, it doesn't give you that chance to save the file. But he needs to do it from this surface menu where you triangulate and contour, and it has the option right there to write the file. Okay, so that's what I wanted to get him back to. All right. So we'll see when he comes back. I hope he comes back. Let me just pop him a real quick email here. Let's see here, Jack. What's his name? Jack Nelson. And you can use the earlier link to rejoin the Zoom session. I had to quit it for my conference call, but it's back up and running now. I'll also show you how to do the surface file write command inside of takeoff. See you soon. There we go. So maybe he'll know. He may have dropped off and felt like I can't see it, so I don't need to finish up my training. I don't want him to go away disappointed like that. So anyway, he's got that. And if he comes back in, we'll get him rejoined in our effort here. So so what we did, we created this surface. Now let's go to the view menu, 3D view, and surface file viewer, and let's look at some problems that we're going to potentially run into having used those contours only. And so we're going to open this and we're going to see our surface. Now, there's a number of things. I'm going to go to my settings tab. Or my model tab. You don't need to do this, but I'm just going to do this for some reference. And I'm going to grab all of these things and bring them in to overlay my surface that I built. And we're going to talk about can you all see these contour lines okay? Or are they too skinny that you don't see them very well? Let me see if I can set the line weights. Yeah, let's do that. So if these are the original drawn contours, but if you look at the triangles that formed, that's what you're going to see here where they're not colored in. Here they're colored in. So if you look at the triangles that formed, you can see here's a flat triangle in here. So this contour line, that point looked across and saw that contour line. That one's correct, but it also looked across and saw, oh no, this one, see how it looks across and it sees itself. This contour line actually comes up here and then backs away from itself. So, or actually it's in, let me see if I can get some shade. There we go. It's a little better. So right in here, you can see how it set on that point and it looked across here and saw itself, and it assumes this to be that flat elevation. Now this triangle is correct in and of itself that it goes from this point down to that point and from this point down to that point, but this one's flat. This one is also flat because it's connecting over to itself because we didn't have those break lines in there. Okay. So what that means is even though we managed to get this surface built without any errors, and we can see things like this little pond over here and this pond over there, and they look like, well, okay, we've successfully modeled our ground. Well, notice the difference, and there's a couple of other things to notice here as well. If I uncheck this, you see all these skinny triangles over here? We need to limit those. All these long skinny triangles out here on the outside edge, we need to limit those as well. Okay, and we're going to put a boundary around our data to keep those triangles from forming out there over the open space that it can look across. All right, so we'll do that as one step, but we're also going to notice if I spin this up, turn it around so I'm looking down my road. Look down that road edge. Let me turn those contours. Major. Let me turn those contours back off. So if I'm looking down my road edges, that road edge should be nice and crisp. And you see, it looks like a set of stair steps, right? And that is a direct result of having built that contour. Let me turn the rest of those off. That's having built this surface from those contours. And this is the interpretation it comes up with. Notice again, right up here where this little retaining wall is supposed to be, I've got like, Park City, Utah back during the Winter Olympics. I got my nice little ski jumps up there. So that's not very well modeled in that particular location. So I've got a bunch of issues that I'm going to need to take care of. And I'll show you what we can do with that. So let's exit that. And we're going to do something here that's going to clean up our triangles out in our little areas that we don't know about. And we're going to do a particular switch that's going to at least help with those flat triangles. So you can simply draw a polyline. And if I do that, I'm going to put this on a layer called C dash surf dash boundary. Set my color to be by layer. So it's going to build that. And let's say if I just do a line, of any arbitrary shape, there's going to be my polyline. And that's going to be on that surface. And let me fix that so you can see it. That is going to be red. And it's going to be 0.5 millimeters. So now we can see it. So I could draw any arbitrary shape. And when I build this surface, let me draw another one and I'll do it on the inside here. And we're going to use a particular switch here. I'm going to go to my surface menu, triangulate and contour. Now I'm going to leave the file name set to be the same. It's going to ask me to overwrite it. I'm going to say okay because we're, stepwise improving. So one switch I'm going to do right here is I'm going to choose to use inclusion, exclusion areas. And I'll say, okay, say, yes, it's okay to overwrite. Now it says on my command line, select entities. Well, don't get ahead of the game and start selecting all the data. Read the line above it. It says select any inclusion perimeter polylines. So you can have more than one. But in this case, I've just got the one. It's going to be this outside red line. I'll click that. I'm through selecting. See, it says entities and set one. Select entities. I'm still selecting inclusion perimeters. I'm going to hit enter to finish. Now, select entities is still there. At this point, and honest to goodness, it took me weeks when I was first learning to use the software to quit jumping the gun because I would say select it. Oh, I'm going to model it. No, read the line above. Select any exclusion polyline. So I'll select this little inside polyline I drew and hit enter to finish that up. It still says select entities. Now at this point, I'm going to select all my points and break lines, everything I want to include. I'm going to grab everything. Remember, it's going to ignore everything that's at 0, and it's going to limit the inclusion to within this, and it's going to exclude what's within that. I do that, my file comes back. I'm going to go back to view it in my 3D viewer. There it is again, and you're going to see, I've limited it. So if you've got a huge amount of data, but you're only working on a part of that as your work, you don't need to build all that other stuff. So you can limit that, and you can even exclude certain parts of it. Now, what is an example of some of these exclusion perimeter polylines? What about these building footprints? I don't know what the ground looks like underneath those. So I would probably select all of those as my exclusion boundaries. And yet I want to keep everything else as my inclusion boundaries. So we have a tool, and again, you could just say draw a polyline, and you could just, eyeball your way around all this, and this would be perfectly fine. Again, it doesn't have to necessarily, uh, you know, some things can stick out. It can be a little further in, what have you. That would work. And you can also have that particular polyline. It can have arcs in it. It can be whatever. It's just a polyline, just a 2D polyline. So I could do that and just eyeball it. And that's probably even the fastest way to do it. But there's another tool called shrink wrap entities. It's on my draw menu, and I want to draw some shrink wrap entities. So if I do that, I have two choices: go across the gaps or use bounded line works only. I'm going to go across the gaps so that I'm going to allow it to go from end to end to end around the ends of all of this little line work. I'm not going to need it to be continuous. I'm going to select my surface and put it right there on that same layer so it shows up for us. Give it a maximum gap. And if I do a perimeter reduction of none, remember that in our triangulate and contour, I had to choose that perimeter reduction of none. And here's where it comes into play. I'll keep it at a 2D polyline. I'll say, okay, and I'll just grab my data and hit enter. And that is what that did. It had a problem right in here. Let me see. There's Jack. Welcome back, Jack, as they say. Sorry, I had to stop our session to take care of our conference call project that I was working on. Um, so, uh, anyway, all right. So anyway, I noticed you said that you had a problem. You couldn't get you couldn't write the triangulation file because you're using Carlson 22, but actually it's not because you're using Carlson 2022. It's because you can write the file in that. It should be because you're using the construction module. Is that correct? And you may have to go through the chat. I can't remember if you had the mic or not. Oh, you found the option in the middle of the menu when it was on top. Oh, so you went to the surface. Now you're in construction. So you went to the surface menu, triangulate contour, and you're saying instead of being up here, it was down lower, correct? Okay. All right. So now you know where that is and what we got. So now we're talking about refining what we did here a minute. So if I shrink wrap all my data, I'm going to draw shrink wrap entities. Let's get this maximum gap. I'm going to bump that number up to say 1,000. And I'll say, okay, and I'll do this. There we go. That's what I was looking at. So now, if I shrink wrap everything and I don't do any perimeter reduction, it leaves this. So it didn't really shrink wrap. It didn't snug itself into the data here. It just went all the way around, and I gave it a maximum gap of over 1,000 feet. So it goes from that point, and it can see this point up here, and it's less than 1,000. So it just wrapped around that corner. So it goes to the outermost pieces and draws that. So you see, I've got missing stuff in here. I've got missing stuff in here, missing stuff in here. This is this would be the same result, excuse me, that we did the first time we looked at that surface where we didn't use the inclusion perimeter polyline. And this is called no perimeter reduction. So I'm going to select this and change its color just so you can see the difference in what we do next. So if I say draw shrink wrap entities, and this time I'll keep the gap the same, but I'm going to change my perimeter reduction from none all the way up to high. I'll say, okay, I'm going to grab everything. I'm going to type R to remove from my selection set, and I'm going to remove that yellow line and let it do that. Now you can see what the difference is. In fact, I've got a little stray line in here. So I'm going to get rid of that one, and viewers may or may not have done exactly the same as this. But in any case, it should do something like this. Now look at the difference. This line actually walked around and it closed up, because what it was surrounding was this line and this line and this line here. So you see, here's that gap. So it shot inside to have found another, okay, here's another gap. But instead of jumping the gap here, it jumped it to the inside because it's reducing the perimeter, what they call that perimeter reduction factor. So it's reducing that at a high rate as opposed to this yellow one, which was a none reduction. Now, I'm going to select that one and change its color to cyan, so you can see that difference. We'll do this one more time and draw shrink wrap entities. And this time, instead of high, we're going to set it to low. I'll say, okay. Select my entities to shrink wrap. I'll select everything here, and I'm going to type the letter R to remove. I'm going to remove that yellow one, and I'll remove that cyan one. And we'll see what this one does. Now you can see It's not quite so aggressive cutting in because I did only a low reduction. So this one is now, like right in here, you see it's jumping the gaps between the ends of uh, all of these lines. That's the across gaps. It's jumping those gaps. And earlier with this blue one, here's a gap, but it was trying to get rid of any extra stuff out here a little more aggressively. So it goes in until it hits the end of that line and jumps across and comes back out. Same thing here. Jumped in, walked up, came back out. Now what's going on is this. When I run that command, here's another case where I've got, I might want to do some adjustment there. So what's going on is this in the three different cases that we've used. When I shrink wrapped everything and said no reduction, what it's actually doing is building a surface really quick in memory out of all this data. And so you get those triangles out here like we saw the first time we viewed our data, when we viewed that file. And so it recognizes that I'm going to have some triangles out there on the perimeter. And so that's why that question is staged such that it says shrink wrap entities. I choose to perimeter reduction. That is basically how aggressively do you want to examine those resulting temporary triangles and start to get rid of them. And if I said none, well, it kept them all. That's what the yellow shows. If I said high, then it went around the edges and snugged up real tight, and it got rid of even some that probably should have been there. They should have been okay to go across the gaps. When I said low, it would be the resulting red line that you see. So it's just a matter of the degree of effort that it puts into getting rid of those what would be those outside triangle edges. Okay. So again, you can simply draw that line or you can use shrink wrap to create a line. Okay, and so we're going to I'll go ahead and just cancel this, and I'm going to erase those objects here. I'll erase that guy and that guy and that guy. Must have missed. There we go. So I'm going to come back to this and I'm going to draw another shrink wrap. And if I did, I would set my reduction to low and leave it, let it do its thing. And that would be the line that I would use for my inclusion. However, instead of having to do it there, look at your surface menu and let's choose triangulate and contour again. And this time, if you said, don't use the inclusion exclusion areas, it still will offer to shrink wrap that for you. And again, you can choose the amount of reduction. If you say none, the setup is gray. If I say low, my setup button comes up. So I'm going to click that. I'm going to draw a 2D and I turn it on that I want to draw it. And I'm going to put it on that same layer so you can see it. I'll say okay, and then say okay. Confirm that I overwrite. Reading my select entities, read the line above, it says, it no longer says select inclusion polylines because I'm letting the command take care of that for me. I unchecked the use inclusion exclusions and I said perimeter reduction is low. And I'm now going to draw a window around everything to triangulate, and off it goes. And it is going to draw around my site because I went into the setup button and said, turn this on, or to draw this line. Now I would, a lot of times we get by without having to create this line to begin with and just let the command do it. However, here's the problem is if you rely on that only comes into play is if you uncheck this right here, use inclusion exclusions. If I want, and that's fine, you can let it do that. You don't even have to draw it. But if I want to use that as my inclusion, which it will do by default, there's nothing as part of that shrink wrapping in here that will allow me to still select my exclusions. So if I want to cut little holes where those buildings are, I need to tell it I want to use these inclusion exclusion areas first. And so now this shrink wrap grays out because it's not going to do it. It's going to rely on me to pick it, and I have to have them drawn. Okay. So that's what I'm going to do. So I'm going to draw this thing first. I'm going to come out here and erase it. And I'll just draw shrink wrap entities, cross gaps, that layer, give it 1,000 feet maximum gap, a low reduction, a 2D polyline, grab everything, let it do its thing. So now it did its thing, and it actually even included this building down here because that was part of it. The interior one to the command skipped past that building because it was probably at 0. And so you can do a couple of things here. Again, it's just a polyline. If you want to modify this to maybe, convert that to an arc and snug it up, maybe, get rid of, a vertex there and maybe this one here. So you can do all of that little cosmetic stuff and straighten it out if you want, but that looks pretty good to me. I'm going to just leave it. All right. So let's go back to surface and triangulate and contour. And now that we have that one drawn and the building footprints are already drawn, I will use the inclusion exclusion areas. I have the choice to trim the triangles or trim the edges or remove the entire triangles that might cross it. Well, I'm going to trim them because I want to keep even, the partials. And I'll say, okay. And I'll say, okay to overwrite. Now, again, read your prompts, read the line above, select the inclusion polylines. And again, it could be more than one. So you could be, phase 1, phase 2, whatever. And I will select that boundary. I'm through selecting inclusions. I'm going to hit enter. It still says select entities, but now it tells me to select my exclusion polylines. Now, these all have to be closed polylines. So now I'm going to come up here and I'm going to pick this building footprint. I'll select this building footprint. I'll select this building footprint. Come up here and select this building footprint. Now, these things that are canopies, they're just overhead canopies. They're not going to be used anyway. This is ruins, and I see I've got a contour running through it. That's just an old concrete slab, so it's actually going to be part of the surface, so I don't want to cut a hole in that one. So I've got 1, 2, 3, 4, and then down here is maybe another building. So I don't know anything about those areas, and I'll hit enter. I'm finished selecting my exclusions. Now select the data you want to triangulate. So I'll grab everything and hit enter, and off it goes. It builds my surface. Now let's look at the difference. So if I view that surface, now the same name, you can see all of those outside edge triangles that used to be out here and down here, they've now been cut out, and you can see they're cut out where the exclusion perimeters were as well. Okay, follow? Now we still haven't fixed our little stair steppies. So how do we do that? Well, let's go back to surface, triangulate and contour, and now we're going to keep the same name. We look down here in this bottom area, and there's 2 boxes. You look on yours, you can barely see them on your own screen. I'm sure you can't see it across the Zoom screen, but there's a little faint gray box drawn around these 4 check boxes and another one down here around these 3 check boxes. The one is for adjustment for source data of contours, And the other one is adjustments for dense existing ground source data. So, Jack, you being the drone guy, and if you're trying to use this command to build a surface out of a whole bunch of laser scan points, I would probably look at that surface simplification, but I would use probably Carlson point cloud to do my surface building anyway from that. But anyway, beside that aside, so one of the things I want to do here for these source data of contours, remember I told you we had those flat triangles? If I turn this on to minimize flat triangles, and the only time I want that on is if I'm reading contours as my source data. And I'll say, okay, I'm going to limit my flats. Okay to overwrite. Pick my inclusion. I finished those. Pick my exclusions. I'll grab these. And that one. Now, oops, I must have missed. See, I told you, read that line above and I missed doing it. All right, so pick my inclusion. I think I finished, I think I didn't conclude that. Now my exclusions. So that one, that one, that one, that one, and finally this one. Now hit enter. Now grab all my data. And now let's look at the difference. If we do our surface file viewer, again, the same surface file, I'm going to spin this up. I'm going to look over here now, and in comparison, if you remember, walking down that road edge, I had all those flat triangles. Look how that's cleaned that up. Now, it's not perfect, because I've got some down here that are still getting in the act, but I've tried to minimize it. I've really got some up in here on this side of it, and that's because that's a raised sidewalk area. But you can see it's really got some issues here that I need the break lines that are going to define that top edge. Because right now, the surface says it goes here at this high point, it drops down to the road surface, climbs back to the high point, drops down to the low point, back to the high point. And really, that should be all the way across. And it should be something that looks like this. If I well, okay, you can't. Let's go from a point here. Maybe from here to here. And then across the top as well. All right, so you should see this is as if I had used those. And what else? Got where I was. Yeah. So this would have been, had I used those break lines, you see how now I've defined that edge. Still got one more in there from right there to right there. So it won't let me from here to here. Hmm. Well, regardless, you see. So that would be, one way that I need to further refine this, and minimizing flats did not fix that for me. It didn't fix some of these over here. And I still have our little ski jump over here by this wall. Okay, now let's do this the correct way. Let's turn all our layers back on. So I'm going to go to View, Thaw/on all layers. And I'm going to select my other boundary that I drew earlier and erase that for now. And now what I want to turn off are not those break lines and points where I'm using contours, but I want to use just the break lines and the points and anything else that's at 3D. So I'm going to freeze off a certain set of layers. So I'm going to go to View. I'm going to freeze by selection. So I'm going to zoom in here and let's select. I'm going to click the mouse, drag across it. Maybe pick those two here. So now I have selected an index contour, the index label, the intermediate contour. I'm going to go over here and select my obscured contour indexes and intermediates. And I'm going to also just get rid of that spot elevation. And so now all I still have the original polylines here, but I've got a little bit more data. So this aerial mapping company actually, they build all their stuff out further and then they trim in about 50 feet and that's all that they deliver. So that was why this goes out here and you didn't see this stuff across the road yet. So let's draw our shrink wrap on this data now. So we're going to draw shrink wrap entities, keep the same things here, the perimeter reduction. And if I say ignore zeros, it won't pick up those building corners. And I'll say, okay. I'm going to draw around that and let it do its thing. There it did its thing. It's relatively smooth. Maybe tuck that up inside a little bit. And now you can see it's a little bit more chippy choppy in here. And so I want to get rid of a few of these vertices around there. So I'm going to remember that tool I told you, remove polyline vertex. It's on my polyline toolbar. So I choose that command. It prompts me for the polyline. I'll pick it and it just shows me these temporary markers. And I'm going to just pick near, and it's the nearest one that I click near is the one it's going to get rid of. So I'm going to just sort of click my way around here and see how very fast it works. And then maybe over in here, I'll get rid of a couple of those.
Where is that selection again, that tool you're using?
It's called Remove Polyline Vertex, and I took it from the Polyline toolbar, but it's on Edit, Polyline Utilities, Remove Polyline Vertex.
Okay, thank you.
Bet. So all I'm doing, and there's no need to really worry about doing that, is I'm just, smoothing that out a little bit. So when I build my surface, it's going to go out there nicely and smoothly. So I'm not going to take the effort to do it and go around the edges and trim it all out. But what the point I'm making here is that this is just a polyline and you can edit it and do anything you want to with it. You could have just simply drawn it freehand as long as it included what you want and clipped out these areas where those long skinny triangles would form. So now I've got everything that I need. And let's go back now to surface, triangulate and contour. And this time where it says write the triangulation file, I'm going to hit select. I'm going to change the name. So I'm going to call this one EG-VKLN-. SPOTS. So existing ground from break lines and spots. I'll save that. Make sure I have use inclusion, exclusion is turned on. I'm going to say I can uncheck now this flat triangles because something in the data might give us a flat triangle and, it'd be valid. And I'll say, okay. Reading my prompts, select my inclusion perimeter, that red line. I'm through selecting inclusions. I hit enter, select the exclusion perimeter. So I'm going to grab my building footprints. So I had those 1, 2, 3. I'll leave the ruins. I had this one over here. I think I'm missing one right there. That one right there. All right. So 1, 2, 3, 4, and 5. I'm through selecting exclusion polylines. I hit enter. And now select all the data. So I'm going to grab all this data and say, go work on it. Now, here is an interesting dilemma. We actually found some errors in this modeling from this supposedly better data. And anytime you have that, you're going to get this little error box that comes up, and it's going to show you, you can have 3 potential classes of errors. You can have crossing break lines, you can have vertical edges, and you can have T intersections, which is basically a crossing break line that just doesn't go all the way across. It just sneaks up to it. Now, all of those things can happen, except the problem is if a line crosses or meets it at a T intersection, it's only if it has a differing elevation will we see it show up here. So it tells me I've got 3 crossing break lines. I've got 2 vertical edges, and you can look at these settings where you can put in the tolerance values and all of that. But you open up these particular places and it shows you in parentheses, what's the difference in elevation at that place where that crosses? Well, it's 0.32 feet. Well, that's pretty high. 0.07, and you see a little marker out here in the drawing that jumps around and shows you where those points are. So if I set to 1 here and it's pointing right in here, I can say zoom to. Well, that just puts it in the center of the screen. And then I can click zoom in until I recognize, oh, I see, there's my problem. Zoom out a little bit. So I could fix this. Now this happens to be a head wall of there's a culvert that runs through here, and that's the head wall. Well, it actually runs this way. And so that's the head wall of the culvert. So when the aerial mapping company, remember I told you that they're really fast and really good at this? Well, here's an instance where they got a little too fast and they allowed these 2 lines to cross each other. One of them, like this one, you see, that's represents, either the top of the wall or the bottom of the wall, but it's crossing. See how it crosses right there? It also crosses right in there. And if I look at where it actually finds the difference is right here. So, you could either uncross that or you could just accept the error and live with it. Now, if I look at these, I'm going to select that one, I'll hover in that, and I read that elevation on my status line. It's 1313.93. In fact, let me fix these so you can see them a little better and keep them separate in your mind. All right, so if I look at this red one, it has an elevation at that corner that's 1313.93. If I look at the yellow one, I see its corner has an elevation of, if I can get it to snap into it there, 1313.63. So it's a little bit lower. The red one's higher. Let's look at it down on this end. The red one is 1313.13 and then 1313.04. So the red one's higher there. I look at it up here and I see it is at 13.71. I look at it here and it's at 13.66. So this one actually crosses it too high. This one's too low. So, but the thing is, you would need to uncross this particular line. So what I'm going to do is if I look at that, I see that's on the inside of it there. I could just grab that grip and just stretch it so it's all on one side of the head wall. Now I may be putting it on the wrong head wall. And what I would really normally do is I would maybe send that back to the mapping company and say, hey, fix this problem for me. I don't know how to interpret it. So I've now resolved that, and I would say exit, and nothing happens. It just exited. So to get it to see if it fixed it, I need to run the surface, triangulate and contour one more time. Leave everything like it is. I'll say, okay, yes, overwrite, find my existing, no more existing, find my exclusions. I said existing, I meant to say inclusion. So here's my exclusions. So those three, that one, and finally this one. And now select the entities. Well, instead of drawing a window, I'm just going to type all and hit enter. Off it goes. So I've now fixed one of those. I only have this one crossing break line right here, and zoom to it, zoom in. And it's where they've actually, if I zoom in far enough, you can see it actually sticks over. Ignore the blue ones, that's the zero. So this one goes out to the blue, and it really should have been, you know, back in here so that it doesn't cross this line. The blue lines are the zero plan view lines that were not actually triangulated. So I may have fixed that, and then I've got these vertical edges. Let's see what that might represent. I'll zoom out. That's again where the curb comes along and it meets another one that was done from another pass from another direction. Now they're very small, 0.04, 0.01. I'm not going to bother to fix those. I'll just say exit and live with those repairs that I may have just finished. I'll run it one more time, surface, triangulate, and contour. Say okay, confirm to overwrite. Select my inclusions. Now select my exclusions. And then finally that one. And select the data now to triangulate all, enter. So now I'm back to just having those two vertical. So you see how you clear out the errors that it might find. I'm going to live with those. They're close enough. What happens when it doesn't know which one to use, it will use one and disregard the other. So I don't know what it's going to do. We'll just let it do its thing, but I'll never see that distance. Now, let's take a look at this file. So go to View, 3D View, Surface File Viewer. This is now my EG break line spots. And when I look at this one, look at the difference. Not only did I see all of those flat edges, those flat steps go away, and it walks right down that edge. But look over here on this edge, you see now all of those break lines have been created. But look what else we saw that we never saw before. I even have these curbs that are nicely well defined. Okay. And across the street, I've got these retaining walls, these little step ups from the curb. And remember our little ski jump that was along this feature in here, that little loading dock area? Now, if I look at it, you see that's a nice, well-defined limitation on that data. Use that 3D break line and now made that as a surface. I can compare these two surfaces inside the viewer if I want. I'm going to go to my model tab. And I'm going to choose this button to add the model. And I'm going to add the other model, the contours only model. So I'll choose that, and it's going to show up and be part of, I'm looking at both of them together. I'll open up the surfaces and I can toggle one of them. I can toggle them on and off like this. So there's my original existing with all that mess. And I'm going to turn my revised model on and then turn off the original one with the mess. And you see the difference between the two? So when I don't have this on, I have no curb definitions. I've got all those little ski jumps. I have some flats, but most of them are, look at this mess in here. So if I turn this one off and then turn it back on, see how it's now picked up those nice wall edges and those curb lines? That is a good surface, okay? There's my pond. You see how nicely and well defined that pond is, this little pond in here. Okay, so that's what we're after. We want to make sure that we have all of that kind of break line information created and modeled for me correctly. Okay. So when you see something like that that has that kind of definition, you should be pretty comfortable with it. I'm going to zoom down here, and right there's our little head wall. Remember seeing that head wall? So we fixed the errors. Now I may have gone to the wrong side, so it looks like it jumps in and back out, but we got it to quit being an error. And so that would be something that I would be very confident in using to compute volumes from, or to use as a design base. One other thing I can do with this is on my settings tab is I can display the contours. And so that's what those contours would look like. And this is a contour interval of 1 foot. If I wanted to just see them every 2 feet, every 5 feet, or every 1/10 of a foot. So you see what it's doing is it's actually computing where those contours would be in real time and just in memory and showing them to me here. Okay. Now let's compare what they look like against, well, I'd have to go back and thaw the layers back out. So I could look at these others. So if I go and turn all of my layers on, and let's now freeze my break lines. See view. Freeze by selection. I'll grab a couple of those points in there. All right, so now if I look at that surface again, my break lines and contour, or break lines and spots surface, there it is with the contours showing. If I go to my model tab and choose add entities, let me just grab everything out here in the drawing and load it on top of it. And let me go to these. Tone my lines down a little bit, and let's go to undisplay my contours. These are the actual contours that they gave us. Now watch, if I zoom into this area and you see they're sort of convoluted here, I'm going to turn mine on. These are the ones that would compute. And you see how they match? You see they come all the way up here and come all the way back down. Okay, so that's a good confirmation that we are matching, what they said it should be. Here's some that as they go across the curve, you see it comes down here, walks down the curve and comes across. If I look at mine, you see they do the same thing. Okay, so that's pretty good. Now you're going to find a couple of little places here and there, maybe, that they're slightly different. You'll also see your computed contours. They won't clip them. They'll always show them. There's that little wall edge. Up here, these are all, see, those are all contour lines across that loading dock. But you're going to see like right in here, you see the ones that they gave us. I'll get my pointer. Or is this green one? The computed one is this yellow one. Now those little bit of misfits on those contours are due to some, perhaps some contour smoothing, some kind of algorithm. Here's another one right in, let's see, I thought I saw it like right in, well, it's still pretty tight. Oh, right here. So, you know, my computed yellowish looking contour versus their drawn green contour. So their program created the green contours. Here's another spot up here where it's just slightly off. And they may have had a smoothing algorithm in play that slightly adjusted those contour shapes. Okay. But we got a real good agreement with that. Okay. So if I exit this and let me go back and look at that original surface, which was my contours only. And there are those contours. Now I had the flats on, so that part, or I had the flats to be minimized, but I still got this over here. And so if I compare that to their delivered contours, now you're going to see areas like right in here, of course, where they are obviously different. Let me step up that line weight a little bit here. Let's see. Yeah, so here, because of all of those flat triangles, you see the green triangle is what it should, the green contour line is what it should have been. These yellow ones are where it's computing, and that triangle right in there, those particular triangles are all flat. Here's a place where it missed in there. Okay, so there's a lot more differences. Now, because I had minimized flats on, you don't see the problem over here. If you did, our contours would come up here and jump across. They wouldn't go all the way up to the ends of the noses. So you would get something like that. In fact, I will do that one real quick as an example. You don't need to worry about doing this. But if I triangulate and contour, delete surface, triangulate and contour without minimizing flats. Whoops, no. I'm going to choose the contours only. There we go. Now, yes. So off it goes. It drew this other boundary. I'll go ahead and select that and get rid of it. And I'll restore my layers. And now I'm going to view that existing by contours only surface, and it's drawing the contours. So you can see as they come up here, they square off. If I compare them to my drawn contours in the drawing, you're going to see now, you see that's where all those little flat steps were. So if you see the dark green edges, those are the drawn contours, and you can see my computed contours and sort of squared those off. They should have come up all the way up to here and back down, but it didn't. It created a flat triangle in there, and that's why those contours don't match in those shapes. Okay. Key takeaway here again is to recognize that you're going to get things like this, and you're going to run a command to build a surface, and it's not going to give you any errors, and you're going to be all happy about it. And yet, if you don't look at this And you don't see, you know, I don't have any of my curves, nothing is defined like we had it with that other surface, okay? So that's what I mean by use your eyes to visualize this stuff, to analyze the differences in them. Show you another real quick sample of how we can analyze this, not even using that 3D viewer. Let's go to the surface menu. No, let's go to the, oh, I'm still in takeoff. I'm going to switch back to survey. And I'm going to go to the, where is my quick, oh. Well, I want my quick profile tool. It's on surface menu. Yeah, there it is. So if I go to my surface menu and choose quick profile. Now this is going to let me, now Jack, you won't have this. You have the quick profile command, but it's only going to look at your existing ground and design ground where you've done the make existing ground, make design ground, instead of making them from the triangulate and contour command. So you're not going to be able to see exactly the same way with this tool. But right now I'm going to tell it that I want to look, I'm going to compare these surface files. I'm going to look at what I see in my quick profile. I want to read a surface file, and I'm actually going to read two of them. If I only wanted to read one, I would come down here and these names stay from the last time you run it. So I'm going to go to this second and just hit cancel, and that will clear out the name. So I'm going to do this. I'm going to take my first surface and I'm going to use that break lines. And I'm going to compare that with my second surface to the ones from the contour zone. I'm going to say open. So I'm going to look at these two surfaces as a profile. So I'm going to say, okay, I'm going to read the prompt. It says pick a starting point, or I could choose a centerline file or a polyline. So I'm just going to come down here and I'm going to pick a point, say here in that nose, right along that edge of that road edge. And I'm going to click another point and I'm going to hit enter to finish. And now I'm going to see as I move this along that area, I can see a little tracker up there where I'm looking at. And as I track down here in my profile view, and let's put this on, say, a bigger vertical exaggeration. Let's do that one. So you can see right in here, you see the red surface is my old existing surface. And you see how that flat triangle is there, and then it sort of does okay down through here, and I get down in here and there's a flat triangle. But you're going to see this also very quickly. I'm going to come over here and choose adjust alignment. And I'm going to leave that one point there. I'm just going to pick a point and drag across the ground over here. Go back and adjust alignment again. And I'll sort of go perpendicular across the road. And let's see if we can see some differences there. We don't really, we see it here. The white surface is my well-modeled surface. The red one is the contours only, so it matches in places, but you can see as it comes down there. Now let me switch this. I'm going to switch the adjustment or switch the direction to sort of mirror what we got. And now let's adjust that alignment. Now watch what happens if I click near the middle instead of the ends. And if I move this around, you see how it's in real time. So if I'm going to look at it right in there, and I can click that down or bring it up here, you know, any of these different places. Let's see if I can find, like right in here, for instance, I click right there. So right in that area, if I track along here, and I'll click down here in my profile view, and you see that little flattened in V area. You see over here where it should have stepped up and had that little raised sidewalk. It just ignored it when I did it from the contours. And there you see that the little raised red line. If you can see that, I don't know how well it comes across the system. Now, one other obvious place that would be changed, I'm going to adjust the alignment again. I'm going to pick near that end, and I'm going to come up here and let's plop it down, say right in here. And then I'm going to go back and say adjust alignment again. So I can only do this one point at a time. So I'm going to cut across that little parking island there, and I should see that. So I'll watch my marker now as I move back and forth. And you can see the white line in my profile view, that's my well-modeled surface that shows the curbs, comes up across here, and then it jumps up and climbs the curb. You can see as I get right in there, you can see where it's tracking it correctly. Okay, and then there's some other obvious, up here's another where it drops off the curb right in here. So my red surface was that original from contours only, so I don't get that. If I were to try to build a drainage system based on that existing grade, I'm missing a lot of key information, okay? Another quick, I'm going to adjust my alignment again. I can't seem to, there we go. So if I'm going to line up and look across, there's across in front of that loading dock. And you see this big red hump in my profile? If you can see those colors and such. That's where you saw all those contours out there. So this is another means of just verifying to see if things look like what they should look like. It's called quick profile. All right. I'll exit that and come back out to our drawing. And that's the essence of building surfaces and making sure you use all of the data that you have and make sure you use the best available data, which is not it's not ever contours. Contours are probably the worst data that you can use to build a surface from. However, it's what a lot of people do. And if you're in the business of creating contour maps to get to an engineering firm, you do your work well and you come up with this nice contour map, if all you give them is a drawing that has contours in it and expect them to build the surface from those contours, they're going to run into these same problems. So you should consider including as part of what you deliver all of the break lines, all of the individual points that you use to generate your contours with. Okay. Put them on a separate layer. They can freeze them, get them out of the way. There's another way to give them that surface information as well. I'm going to undo that to turn those back off. But you can actually send them, first of all, if they have Carlson, you could just send them the .tin file, that one called EG-BKLN-SPOTS. You could send them that directly and they could work with it and go. But let's say they use Civil 3D and they don't use Carlson. Well, Civil 3D can't read a Carlson tin file. But if you go to the file menu you have an export function, and right here is this land XML. And that's how you can send out not only surfaces, but all your Carlson points, your coordinate points, any parcels, any alignments, any profiles, any pipe networks. It's a standard and universal format that all of the different civil design software, including the ones from Bentley, like Open Roads and InRoads and MX, and you've got Civil 3D, land development, all those different things can read that file. Okay. And if you include that, they can take that and import the land XML file and use it as the more detailed surface information. So I would consider, if you're, like I said, in the business of creating these as existing conditions mapping, find out what they're going to use it for. If they need it to build a surface, find that out and then just offer to send them that additional information. As long as you're sure you did it right, you don't want to embarrass yourself. So make sure you've created those correctly. And if you have, send that information along to them so they can gain that extra accuracy without having to try to guess. Okay. And that now is the essence of our terrain modeling. Questions on any of this? Let's see, Jack, I did see that you said you do use a different software with your drone and then bring it into Carlson. That makes the most sense anyway, because the drone is doing some specialized capture and stuff like that. So I don't, a lot of people use like Pix 4D or some kind of other, well, Pix 4D was typically done from photographs instead of LiDAR. So there, it could be any number of different ways to do that. So that's probably the, still the preferred workflow for you. But then once you bring that in, you've got a surface now into Carlson, perhaps, that you can use. Maybe you bring it in with this import function, import as a land XML file, or it could be a 1,2D file. I don't know what that even is. It's something, some other programs format. So, you have already got that figured out as a workflow, so that's fine. A couple of other things you can do once those surfaces are built, if you look on the surface menu, is down below there are some there's the import export surface data. And again, you can export a Trimble file and a TopCon file. That's to directly make a file that can directly go onto the equipment for machine control. Okay. You can also import those from different sources here as well. There's Land Desktop, Civil 3D. Those are also available back on your file import menu. So you've got that as a means of doing it. But now if you want to verify some things, we've got those surfaces that we did. You can also, under draw surfaces, you can draw the triangles, and that draws them right into the drawing. We don't generally do that because we can go into the viewer and see them in the viewer and come back out of the viewer and they're not in their drawing. However, let's say they didn't give us any contours and we wanted to generate the contours after we've created the file. So what would we do? And in this case, we would choose to contour from a tin file. Now, when you choose that command, that's on the surface menu right here, contour from tin file. So when I do that, notice this. First of all, I'm going to select a file. So if I select this, e.g. break lines and spots, that's my more accurate one. it says, okay, now notice what this looks like. There's a triangulate, contour, and labels tab, just like we saw in triangulate and contour, except I don't have a selection, so I'm not going to be able to filter. I'm not actually creating a new triangulation file. There's also no option to write the file. It's read the file. And now I tell it all the different things I want to use, whether I want to use inclusion and exclusion areas or not. But because my surface was built with the inclusion and exclusion areas already in it, I don't need to re-specify them. Erase previous contour entities. You can turn those on or off. If you say off, then if you draw them, you change something, you want to redraw them, you'd have to erase those separately. Or you could say, go ahead and erase from either the current surface that you're working with or all surface entities. And that means contour lines and boundary lines, everything that you've done to build the surface. You can ignore your zeros, do all these different kinds of things. So the only thing I'm going to do is make sure it says, I'm going to erase my contour entities. I'm going to ignore zero elevations. And then I'm going to go to my contour tab. I'm going to check on to draw the contours. And by method, I'm going to draw by an interval. And I'm going to choose a layer name for my contours. This is for all the contours I have. I'm going to put those on C. Well, let's just highlight that and let's just type index. So it's going to create, let's maybe, let's do this. CTRS dash index. So contours index. I'm going to use a contour interval of 1. And I'm also going to draw the index contours. Ooh, I needed to fix this up here. Contours, not index up here, but INTER, intermediate. And then down here, where I'm drawing the index contours, I'm going to call CTRS-INDEX, index. All right, those layers don't exist yet. It will build them. I'm going to say okay and watch what happens. It's right now, it's telling you what it's doing on the command line. It read the triangles. It's now contouring a particular elevation of 1347. There's something, usually it's done by this stage. Well, anyway, when these finally decide to draw, you should see them lie right over top of these ones that they drew for us. There they are. And so now you can, just like we did before, we could go in and just visually sort of confirm. You see how they sort of match. I see why it took so long, because I have my labeling set to something goofy. All right. So if I go back, I'm going to repeat that last command. So I'm just going to right click and choose repeat contour, read my file, break lines and spots. And this time, let's make sure I go to my labels tab, and I'm going to label the contours, and I'm going to put those on CTR dash LABEL. And I'll just use that. I'll copy and paste for both of these. Use the contour node. Okay, so contour label for my index. I've got a text style called contour label. It could be just standard. It doesn't matter. You can give it a particular height. I'm going to bump this up to be 0.08, or let's even make it 0.1. That's my text size scaler. So plotted 1/10 of an inch at my scale. I'm going to label the index only, align with the contours, draw on the real Z. I'm going to hide the drawing under the label, so it's just going to put a wipe out there. And my distance interval, this is what was taking me so long. I'm going to change that from every 50 feet. I'm going to say every 350 feet. That'll be a little better. And say okay. Now, because back here I said erase these entities, it's going to clear these out and redraw them. So I don't have to go to the effort of clearing that stuff out. Now it's still going to hang up a little bit here on this contour 1347 for whatever reason. There you go, came back much quicker. Now, as you see, I can scroll this around and look, and there's a label there. What is my drawing scale? I'm at 20 scale. So if I change that to 50 scale instead of 20 scale, let's see here, 1 inch equals 50 feet. And let's see, MSLT scale, make sure it's on. Now, if I do that one more time, now notice when these labels come up, you see how small they are compared to how big they are over here. I'm just going to run this again. Now, I'm not going to change, whoops. I'm not going to change that label style. I'm going to choose my file. I'm not going to change the label height. I'm going to still keep it at 1/10 of an inch. But because I changed my drawing scale, watch the difference. Just sort of keep in mind how small that looks compared to this other one. So now I'm going to say okay, let it go through and draw. And now I need to go out here and find a piece of text that's nearby one of the other ones. There's one. So you see that's bigger than the old ones were and closer to being the same size as the one that they delivered. That's probably, 0.125. It's probably an 1/8 of an inch. There's one right there. Now, one last little fun thing is let's go to the view menu and isolate layers right down here in the bottom section. If you click that, I want you to click one of those contour labels, one of your red contour lines, and one of your white contour lines. And so now it's just your contour map that's on. And let's see what you can do. And let's zoom into a place and find a label that is, in fact, let's change. There's my contour label. Instead of it being red, let's make them yellow so you can see them. All right, so there's my labels. Now, also on the surface menu, right where we said contour from the tin file, so instead of doing it when we created it, we waited till we verified it and then we drew them. Then I've got some contour utilities underneath that. And if I look down here, I've got this one that says move label along contour. And if I do that, it says select the contour label to move. So you see how this is all jammed up in here? And this is right in the middle of this corner. So I may select this one. And as I move the mouse, and I don't have to snap to anything, I'm just going to reposition it to be in a slightly better place. Maybe this one now. And I just keep selecting these and put them in a better location. Let's see here, maybe up in there. Okay. So that's when you've done the automatic labeling. You can rearrange them so that they're not in such inconvenient places all the time. And they won't always be, but sometimes you might have them. And if it's a case like, right in here, you don't want to necessarily have it. It's a little too jammed in the corner. And you can flip their directions, and you can even do something like this, for instance. You might not even want to have labels on some of these, like right in here. Well, we know that this is our 1320. We'll bring that one out a little ways here to indicate that. And that's also probably 1320. So up here was another one. Maybe maybe it was in here that we had that label. And so we don't necessarily even want this one. So if we, that happens to be a text and a wipeout together. So if I select that, that's all it is a piece of text and a wipeout. So I can just select it and physically move it with a CAD command, or I can erase it and it goes away. Okay, so nothing special about them, just we use the command to help us create them. And then if we need to rearrange them, we can go to our contour utilities and move the label on the contour. Now that only happens if, when you contour from tin file or do it as part of the command, in your labels tab, you say that you do not say to break the contour at the label. If you do that, where you physically cut the contour line to put the text down, you can't do that dynamic motion. That's why I never use that at all. I always use hide drawing under the label, so it looks like it broke it, but then I'm free to let it slide around, and I don't have to do a move and move it over here and then try to rotate it to line it up. It walks the line and rotates itself to line up, the way the orientation you want. And if it happens to, orient itself sort of backwards, you see this one compared to this one, if one of those was not to your liking, you wanted these to more look like that, you can also do my contour utilities. I'm going to flip a contour label. So maybe I'm going to flip this one here. And you see it just flips it around, but it still keeps it oriented along the direction of the contour. All right. Little things like here is maybe I would have gotten rid of that one, move those out so you can see them, or just delete them all along. But hopefully that gives you a sense of, what you can do with those things. Now I'm just going to view this up here in the drawing, and you can see these are those wall edges, those loading docks and stuff. So you see my contours aren't actually clipped like they did. You can do that. If I go back to my top view, with something here, I'm going to turn my layers all back on now, except I'm going to go back to freeze my break lines. Now, I've got here, and let me select it, give it some weight so you can see it. So there's the outline of that wall. I'm going to select that layer and my contour layers to isolate. So here I've got my wall drawn, but I've got those contour layers, and you see when I draw the contours from Carlson, it just draws right through that wall. So even these nearly vertical faces, you're going to see those continue on. Well, what if you want to trim those out from inside that closed polyline? Well, we have a command there called edit erase by closed polyline. If I choose that command, it says, all right, select the perimeter polyline. That's going to be this wall right here. Blink. And now select anything you want to erase. Well, these happen to just be polylines. I could uncheck all these others, or I could say, yeah, take all of them. And then you choose to erase from the inside or erase the things that are on the outside. So if I say erase inside, boom, there they go. And I now have my contours are trimmed just like theirs were. If I turn my layers back on and let's freeze my 3D break lines again. So now just like they had, see, they had their contours clipped. So I just did the same thing and I clipped my contours out. Now, did I put a hole in my surface? No. All I did was trim, just like if I had selected this line and do a standard trim command and then went pick, 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 pick. But that lets you do that really quickly. Okay, so just some cosmetic type tools, but they're things that you might be very interested in doing. Okay, so now what I would do in this regard is because they had already drawn the contours for me, I wouldn't even bother to draw my contours, but I can always go back and draw them anytime I need. I can go to another empty drawing. As long as I have this surface file, I can draw the contours from it. Okay? Follow okay? So now we need to take our mid-afternoon break and then we'll come in for the home stretch. We'll try to get through as much of that putting it all together exercise that we can. And we'll see where we go from there. All right, so any questions before we take a break? Everybody's good? All right. You may save your work if you wish, or no need. It's always there. You can go back and do some practice and playing around, and you've seen some different things. Oh, by the way, I'm going to go back to view, 3D view, surface file viewer. I didn't show you this. I'm going to look at the good surface. There it is, the way we see it. I'm going to turn my contours off. And there's what we're used to looking at. But remember over here when we were just looking at the drawing elements, I had this color by elevation. And so now you can see it and it's a lot more readily apparent. Here's my low spots. That's my pond. I expect that to be pretty low. This one's, it doesn't mean there's water in it. And here's another one though, it's up higher. It's a perched pond. So, I would see that sitting up there. But this gives you a good sense too of knowing, where your high spots are, where your low spots are, and you can use that to for a little QA/QC. So if you had everything was all blue and then you had one little circle over here and it was bright red, that means you got something that's way too high, and that helps you find those. Just give you a little sense of what that looks like. Now, you're going to see if you go to Carlson's website and look at their YouTube channel and look at some of their videos, they're going to pop in and show you this surface viewer and they're going to do it. And they're going to, a lot of those guys, a lot of those instructors who are programmers or project managers, this is the only way they ever look at a surface is with this color on. I don't know if they think it's cool or whatever, but that's there for that particular reason. To be able to help you visualize that. So don't think that that's the only way that you have to do that. You can do it. I tend not to unless I'm using it to check my elevation ranges, just to make sure they make sense. So I don't see any wacky numbers. Again, you could also put in these bounding boxes, make sure that you don't have, the box doesn't go way down here and pick up a straight point or something like that. Okay, so all kinds of ways to use your eyes to help you evaluate your work. All right. So with that, we're going to take our break. It's coming in at 2:45. So let's come back at 3 o'clock and then we'll spend the last hour and a half trying to sort of tie all this stuff together. We've done a lot in 2 days. Tried to learn about some points. We tried to learn about groups. We tried to learn about drawing shrink wraps and building surfaces. We haven't really built a second surface on top of this one yet to compute volumes, but we'll do that as part of our closing exercise. And that should do us. Okay. So with that, I am going to stop the share. We'll see you back at the top of the hour. And I'm going to pause the recording. And what we're going to do next to wrap things up is this exercise, and it's on printed page 37 or actual page 42, or 43, actually, in the PDF file, but printed page 37 down at the bottom, where it says this exercise called putting it all together, and this is a workflow. Now, we're not going to have time to do all of it in all its various nuances, but we're going to sort of push through to get the gist of it. So I can leave that to you for your continuing learning to dive into the details, but we're basically going to follow this particular set of steps. Okay. Now, we won't match everything exactly number by number, but here's what the deal is. We're going to open a drawing file called example1.dwg. And we're going to see what we need to do with that file to make it work for us. So I'm going to go over here and close off that file that I was working on. I'm going to open files, and I'm going to find now I've got one that's already completed that you can look at that would, show you some resulting contour kind of things. But the one I want, however, is, once this closes, come on. All right, there we go. So the one I actually want to open is just called example1.dwg. If you should get this is the new version of the software because it supports these multiple adjustments. Just choose the middle one there for the 86 adjustment. It doesn't matter. Because these are all just done at arbitrary locations anyway. I look at my coordinates down at the bottom of the screen. I see, I'm at 8,000, 4,000 tracking. So they're just arbitrary coordinates. So what do we have? What do we have here on our screen?
Sorry,
Yep.
Ken, there was something, mine was frozen. Which do we choose when that option comes up?
Just the middle one is fine. It's
Okay.
just telling you that you're not matched up with the right coordinate system. and
Okay.
so it's
Yep.
not going to matter for us because we're in arbitrary coordinates. So you can just choose either one, but I just chose the middle one. Now, so what do we have on the screen here? Let me change a layer visibility here so you can see these a little better. I'll turn on my line weight. So I now have, remember what these guys are? Remember from yesterday, these are our Carlson points, right? So, well, let's see about those points. I see a bunch of point numbers, and I see some descriptions that look like B, 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 all the way on the inside and all the way around the outside. I see B dash toe. So that's my toe of the slope. I have no idea what B might stand for. But let's take a look at all our points. Let's go to our points menu and choose list points. Well, it says, well, wait a minute, you don't even have a coordinate file open yet. And I said, well, what happened? Why don't I? Well, and it suggests looking for a file of the same name as the drawing. So let's, just out of yucks, because we don't actually have a coordinate file that corresponds to these points. That's part of what we want to try to resolve when we're in this drawing. So let's just call this point file stockpile PTS, stockpile points. Okay. It says the file specified as existing because I chose it from the existing tab does not actually exist. Create it now? Yeah, go ahead. All right, so now I've made a file and I'm in list points. I choose all and I say, okay, and there's nothing in my file. There's 0 points, right? Because I have a condition where I've got a bunch of points in my drawing that do not also live in a corresponding CRD file. You remember when we moved a point and asked if I wanted to update the CRD file? Well, these are points that are in here, but they did not actually come out of any given file that I have. So how can I get these points from my drawing into a coordinate file? And while you think about that question real quick, I'm going to jump over here real quick to text styles. I'm going to change that to use a bigger font so you can see it in a true type font so you can see the things a little better. All right, so what do I have here? Set my point mark. Let's give that some weight. See if that makes, yeah, there we go. Now you should be able to see them a little better. All right. So how do I get these points that are in my drawing? And if I double click that point, you see that's point number 2016, but it's not in the coordinate file, but it is in my drawing. So I can work with them as points in the drawing. But if I want those in my coordinate file, so if I lose these points or erase them or whatever, I can go back to them. How do I get those into that file? If you run across that part yet. And this is going to be one of our point utilities. Now, if you go to the points menu, all the way down to the bottom, the next to the last, I get a set of point utilities. And I got a bunch of these commands that I can do. Two of which of interest are I can update my drawing from a coordinate file. So if I don't have points in the drawing or if they're in the wrong position, I can go back and read the coordinate file and reset those, or I can update the coordinate file from points in the drawing. Again, they're either missing in the coordinate file or maybe they've been moved in the drawing, but they didn't update the coordinate file. So you can resynchronize those two to match. Those would be the commands that we're going to be using, but let me show you another place where this whole menu can be achieved from a better tool under points menu. And it's right up here at the top and it says coordinate file utilities, much like point utilities, but it's the Swiss Army knife. So it's our coordinate file utilities and up this pops and this lets you do all kinds of things, even more than that one menu had. On the left-hand side are commands that work with the entire coordinate file. So you can open another coordinate file, you can import points into it, you can export points from it, you can compress it, do some transformation, do everything on an entire file basis. The buttons on the right-hand side issue commands that work on a possibly selected group of points or maybe even a single point. So it works on point by point, whereas these tend to work on the entire file. And again, there's your list points. If you choose that, it's just like you chose it from the menu. You run it, there's still no points in there. It brings you back here. So what I want to do is update my coordinate file from the drawing. So I'm going to choose that. And now I'm going to say, give me, and I could restrict it by descriptions here. Like I could say maybe star TOE, and it would only grab the ones that have the TOE in the description, whatever else in front of it, but not get these points. But I'm going to leave it set to asterisk, meaning everything. And I'm going to say, okay. Now, it asks you to select entities, and you read above, it says you need to select any Carlson, Land Development Desktop, Sofdesk, Inroads, Eagle Point, Geodometer, Leica, or Microsurvey points that might be drawn in this drawing. These happen to be Carlson points, so we're good to go. So we're just going to grab out here, draw a window around everything, select it all, hit enter to finish. And now, what have we done? Well, let's list our points again. Lo and behold, we have 80 points. I've only got two descriptions, B-tow and B. Now, this particular data, I'm going to use that, I'm going to say exit. So this particular data set in our drawing, the only thing in it are these points. I've now also put them in the coordinate file so I could even delete them out of my drawing and redraw them if I needed to. But I've got points with elevations, descriptions, and these are survey points that were done across a small stockpile. Maybe it's a, a stockpile of stone or something that we're going to use on our construction site. So what if we're interested in doing our typical stockpile thing, we want to maybe compute the volume of that stockpile. Now, how do you compute volumes of stockpiles? Or in fact, how do you compute the volume between any given surfaces? Let's say we've got a building pad that we've designed and we made it into a surface called future grade. And it's sitting on top of our existing grade, like we just got through beating our dead horse over with that other set of mapping. So we had an existing grade. We now also have a future grade. So to figure out how much earthwork we need to do to take it from existing to that future grade condition, we would compute the volumes, and that's on our surface menu. And we would say volumes by triangulation, and it usually implies that we're using two triangulation surfaces. So we do one existing and one final, okay? So, so the first thing we know is that we need to make a surface out of our stockpile points here. Okay, so if we do that, in fact, let's do that real quick. Let's go to our surface menu and triangulate and contour. And I'm going to check my selection tab, make sure nothing is filtered. I'm going to go to my contour tab. Yeah, we'll go ahead and draw our contours as part of the process here. We'll draw 1 foot intervals. I'm going to go on my contours layer here, and I'm going to put this on a layer called V-surf -int. That means V means existing or coming from survey. They don't get the S for the layer convention. The structural engineers got in line before the surveyors, so they got the S. So V-surf-int. I'm going to go every 1 foot. I will check I do want to draw my index contours, and I'm going to put that on a layer called V-surf-idx for index. Okay. I'm going to go to my labels tab now, and I'm going to put that on a check that I want to draw labels. I'll draw my label layer. I'm going to put that on V-surf-CTRLBL for contour label. And I'm going to come down here where it says the index label layer. I'll also put that on V-surf-CTRLBL. Now notice I haven't gone out to my layer manager and built these layers yet. I could have, but if I haven't done it yet, no problem. It will build it for me using whatever the current colors and line weights are, and we can change all that in a minute. All right, so what else do we want to do? Well, I want to label all the integers, label my decimals to automatic. I'm going to make 1/10 of an inch tall text. I will come down here and check, do I label index only and go to the side and hide underneath. I'm going to align the text with the contours, and then I'm going to draw on the real Z axis. Then I'm going to go down here. I'm going to go to, you can either like put 1 or 2 or 3 or 4 labels per each contour, but I'm going to go by a distance method, and I'm going to go every, say, 150 feet. And I'm going to say, okay. And now it says, all right, select what you want to triangulate. Select the points and break lines. They're just points. I'm going to grab this and I'm going to hit enter. Off it goes. And there came my contours and my contour
Wait,
label.
could you just pause for a second, Ken? It's prompting me to write the name. You didn't have that step, or had you already created it?
I went to this triangulating contour.
Yeah, I'm in there. I guess I just hadn't done this that part
Exactly
yet.
right. Yeah. That's my oversight. Thanks for catching it.
No, it's okay. I just was a step behind. And I didn't want to miss what you're doing
Oh,
next.
no. That's something I tell people, always write the file. Well, I neglected to do that. So, all right, I'm going to turn it back on, select my file name, and this time I'm going to call this just SP for stockpile. Okay, I'll save that. Now, I'm going to say, okay, now go back and select my data, and you'll see my contours draw and my labels. My labels are pretty high, but it is at 1/10 of an inch, but that's because I've got this drawing set, my drawing set up to be 1 inch equals 50 feet. Well, this is a smaller drawing. I'm going to change that to be 1 inch equals 20 feet instead of 50 feet. I'm going to say, okay. Now, because of that, I need to redraw the contours so that when it puts 1/10 of an inch tall text, it's 1/10 of an inch based on 20 scale, not 50 scale. So instead of being 5 feet tall, it's only going to be 2 feet tall. So I'll just repeat that. I've already built the surface, so I could just go back to my surface menu, and this time I could just say contour from tin file, choose my surface, there's my SP, open it up, and now everything's going to stay the same that I had before. Make sure my layers are all pointing to the right layers, are good, and I'll just say okay. And off it goes. Now our text is smaller. Oh, looks like my interval. I'm going to do it one more time and set that interval up a little bit on my labels. For whatever reason, it switched it to that. I'm going to put it back to 150 and say, okay. Now, why does it erase what I had before and go back to, clearing the decks and putting them on there? Is because in that command, let's just go to contour from tin file. I had it set on my triangulate tab. I said erase all contour entities. Okay. That's why it did this. So sometimes you'll do that and you'll have that switch on and you won't remember that you did, and you'll get rid of the contours you just drew from a previous step. But no problem, because if you've written the file, you can always go back and recreate the contours. Now, so we got something here so far, but what do we actually have? And let's take a look at this a little bit more critically. I've got contours drawn in here, but look at where my slope is supposed to end, at my toe of slope. So I've got some contours extending in here. I've got some up in here. See, there's my toe of slope, should be along here, but it computes a contour out here. I've got some others down in here, same way. I'm outside of my toe a little bit with some of this data. Okay, not terribly bad, but we can really see that, the effects of that. If I go to my surface menu, let's come down here to the bottom, I think, nope, not on here, it's right here in the middle. Draw surface. And let's draw the triangular mesh. We'll read our surface again. We're just going to draw them as lines, take the defaults and say, okay. And there now is the surface. So that's how the surface is actually built. And if I view that surface in my 3D viewer, it looks like that. There's my triangles. And if I look at, these other, I'm going to grab those points. So you see the little highlighted points, but it's filled in some of these areas out here that I like right back here. Those are those long skinny triangles that I don't want. Down here's some more of those long skinny triangles because, right here's my post though. Oh boy. Hang on. Crap. Sorry about that. Pennsylvania is experiencing a temporary statewide 911 outage. So everything I own lit up. All right, so we need that same issue about this shrink wrapping, right? So I'm going to exit this. Now I've got all these lines drawn and I don't really need to have them in my drawing. How am I going to get rid of those? Somebody give me a suggestion. Based on some of the tools that we've used before. All right, so one of the things might be if I wanted to just erase everything here, I'm also going to erase my points, but I don't want to erase my points yet. I've also erased my contours because I still had that set to erase other contour entities. When I drew these triangles, they got rid of the contours. But so how would I get rid of, or even better yet, let's contour from tin file again. And I'm going to say, turn the erasing off. And so now I've got a mess like this. Well, how do I get rid of these triangle lines? The one method might be to what? Go to view and isolate that layer. So if I isolate a layer and pick one of those triangle lines, now I could just select everything and delete it, right? Go back to view and I'm going to restore and show you another one that we could use. And this is one that is very helpful in our iterative type workflows. We're going to go to edit, erase, and we're going to erase by layer. And there's a toolbar icon and it happens to be on our layers toolbar. But if I erase by layer, it lets me select from the screen or from a list. So I'm going to select from the screen. I'll pick that pink purple line. It identifies that layer name. I can filter it, leave it at all and say, okay. So it clears everything out on that particular layer. What if I wanted to erase just the contour labels? Well, you could do the same thing. Erase by layer, select from screen, and you would pick one of those pieces of text, and there it goes to the surf contour label. But notice it keeps the last layer name or names that you had in this list. So keep your eye on that. Sometimes you might try stuff iteratively and now you're happy with things that you had and you no longer want those to erase. And if you just hit select from screen and pick a layer, it's going to add to whatever is already up there. So sometimes you have to hit clear and then select the layers from the screen. Okay, if that's what you're interested in. I'm going to cancel that. I'm going to keep my contours. So now, what do we see? If we draw, let's draw another part of our surface. Instead of the triangles, I'm going to go to surface, draw surface, and I'm going to draw the surface boundary. And I'm going to put this on V dash surf dash BDY for boundary. Just draw it as a 2D polyline. There's my surface. There's my boundary. Let me fix that layer so you can see it. We'll make them red and heavier line weight. And if you're setting line weights and you don't see them, and you have to come down here to the status bar where my mouse is sort of hovering, and there's a little icon there that's a toggle to turn on and off the line weights. Notice my symbols and my boundary are thick or just 1 pixel wide. Okay, so that's where that's controlled. Now, let's look at that boundary. That's the outside edges of the surface, and you would have seen purple triangle edges all along that edge. The contours are there, but you don't see a contour in here, even though the surface is still defined there. So let's, I'm going to erase by layer once again, and this time I'm going to clear, and I'm going to select from the screen. I'm going to come down here and pick a contour label, and one of each of the 2 different type of contours so that I clear out my contour lines. Now you can see the relationship between these toe points and where the surface has actually gone out to. So see right up in here, here's the toe of slope, and it really should come in to here and to here and to here and then back out. That gets rid of those skinny triangles. Same thing down here. It goes from the toe to toe to toe, so it should have cut inside. Same thing up here, should have cut inside and come back out. So it didn't, all right? So how would we fix that? And there's a number of ways. We just looked at that. I'm going to select that and get rid of it. Remember, we did a shrink wrap. And so if we built our surface, we could have gone to surface, triangulate and contour, write the file again. That's where it got turned off. And I would choose that file. And then I would say, if I didn't want to create the shrink wrap to begin with, I would let it do it. And instead of saying none reduction, I might say, you know, maybe a high reduction. And so let's do that. We'll say that. Selecting my data. It's going to draw it. Now, I didn't draw the perimeter. I didn't hit the setup to draw that, but I can if I just go back to surface, draw surface and draw the boundary. Just take OK. There's now the boundary, and that's where the contours are going to go up to. Now, notice here, it did a shrink wrap, and I set it to a high reduction. So it comes up here to this toe point, and instead of going over to this toe point, it tucked it in down here to these B points. So that was a little too much reduction. So I could maybe play with that and see how it pans out. I'm going to select that again and get rid of that. And I'm going to run my erase by layers again. And this time, that's all those contours. I don't need to pick them again because they're still there. So I won't hit clear and I won't pick from the screen. I'm just going to hit OK. Now they're gone out of my way. So now I could shrink wrap this and change that from a high reduction to a lower value, either medium or low, and then look around it, make sure it still worked. So if I recent commands down here somewhere is shrink wrap. Oh, no, I didn't actually do the command yet. So I'll go to draw shrink wrap boundaries or entities. I'm going to go across gaps. There's my gap space. And I'm going to change it from that high down to say a low. And I'll say, okay. I'll grab all my data and see what happens with that. Oh, I forgot to, let me fix that one more time. Shrink wrap polylines. I need to put the layer correct, which is my V surf boundary. And so now it goes toe to toe to toe. It still didn't come in here, right? I missed that one. Looks good around here. I went in too far here. Looks good around there. Looks good around here. So how would we fix that? I could select the polyline and just do some grip edits. So I'm going to hover over this midpoint grip. The menu pops up. I'm going to add a vertex and I'm going to snap to that point right there. I could come down here now and I see this went in too far. So I'm going to hover over that grip and I'm going to say remove vertex. Okay, so I could have fixed it that way. Come all around it. Toe, 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 toe. So I verify, okay, that would do for what we're doing. Okay. Now, alternately, what else could we might look at? Let's look at our points for a minute. List our points. And we look, well, all of our toe of slope points are up here first. So it's point number 2000 down through 2028. That's my toe of slope. Well, if I draw a polyline and start from 2000 and go to 2028, if they are drawn in order around our site, that would do it for me. So let's try that. Let's go to draw 2D polyline. I'm going to uncheck to draw the current properties and I'm going to choose my layer. I'm going to select and choose that V-surf boundary and say okay. And I'm going to say okay. Now it says pick a point to point numbers. Well, I remember from looking at my points, I started at 2000 and I went around to 2028 and I hit enter. Okay, boom, 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 boom. I'm down here ready to finish. It needs to be a closed polyline, so I can either type the letter C or choose the close from the option. So there it is. That took care of it. And it was fortuitous because all the point numbers were in order. And if you look down here, for instance, at 2026, 27, and 28, maybe they were, when we surveyed them, this said 26 here, and we jumped over here and got 27, and we forgot to get this point in the middle. We jumped over here and got it, and it was 28. So in that case, it would come down here, hit to 26, jump to 27, jump with this is now 27, jump over here, come back to 28, and then jump up to, and then it said close, and it would close back up to here. So that is simply good fortune that they were in order. Okay, so that would be what we would normally do. Well, let's do something else we've learned again yesterday is we're going to erase that. We're going to try another means of drawing things. And this would be going to the draw menu, to the polyline menu in the bottom section. And this time we're going to draw a polyline by nearest found. And this lets us restrict it to certain descriptions. But it's going to go by nearest found. So I'm going to choose OK. And the description that I want to match right in here is going to be B-TOE. Or I could put asterisk TOE, anything I wanted there. And I'm going to set my layer name to again be that V-surf boundary. I'll say okay, I'll say okay. And now nothing happens, but look at your command line. It says, do you want to select your points from the screen or by point number? So I'm going to say just choose them from the screen. Now select the points that I want to consider. And I'll just grab all of them, but because I restricted it by description, it's going to draw that around wherever it started. It probably started here and went around and just found the nearest B toe point and connected them. Now again, let's say this B toe point might have been way out here, which meant the toe should have come out here and jumped way down here and then come back into it. But this point could have been closer to this point, and so it would not have picked that up yet. It would have jumped that gap here And at some point, that point becomes nearer to something else. So again, by good fortune, we lucked out using that method. All right, so we can s- delete that. And let's look at one last bit that we might have done. Remember our point groups? Let's make a couple of point groups. Let's go to the points menu and choose point group manager. And let's create, and we're going to, up here in the name, we're going to call this one interior points. And we're going to now, instead of just choosing from a description, let's do it the other way. We're going to say exclude. So we start off by including all points, and now we're going to exclude by description anything that ends with TOE. So I'll put an asterisk TOE and I hit save. And now I look at interior points and my descriptions are only those B points. If I create a point and call this one my TOE points, my toe points, I'm going to not include all, but just do by description. Let's pick it from a list, for instance. I scroll this down, and there's a toe point. So I'll choose that and say okay, and save. And so now my toe points are all the ones that say BTOE. My interior points are all the ones that say B. So now I can control how they look, whatever they want to do, I can draw. And if I'm using field to finish, I can tell it to draw lines between all the points of description TOE, but don't draw lines between the B points. Okay.
Can I was trying this out once and was doing description, and I think I was trying out like set by selection and set from list, and there was something I just couldn't quite get to. Like I was getting some of the points I wanted, but not all of them, or I would think I'd click the right thing. I don't know if you'd be
Sure.
willing to go through that just as an example and maybe try like a couple different descriptions or something if you can put them into one group. I don't know.
Yeah, absolutely. Let's go back to our
Thanks.
group manager. Did you do it with this data set, you mean?
No, I did it because I had a bunch of like
Yeah.
a
Yeah.
couple different codes for the same thing, and I was seeing if I could group them to make the line work easy. It was a bunch of different things. So I was
Yeah.
trying this out as one possible way to deal with that.
Let me do let me do this for a minute. All right, so we've got these 2 points built for us here now. I'm going to temporarily go up here to points, and I'm going to set a different coordinate file just for the temporarily. And let me find some points. Let's go to survey. Let me see, survey, class. Oh, data sets. And let's use this one that's called field to finish. And if I look at those points, I see a bunch of points like this, okay? All these different points, some are the same, some are different, okay? Some are partially the same and some are different. So I can do, let's build some groups out of that. If I go to points, point group manager, now, but see, I don't have the same groups because I switched coordinate files. So I'm going to create a group and I'm going to call these, let's see, spot elevations. Okay, and so right now, if I unclick my include and click on description, and if I set from a list, this shows me all of my points, and I can just pick samples. I'm trying to, that doesn't resize. So I'm going to pick samples. And so I see some points down here called X. Those are my spot
Yeah,
elevations.
this is reminding me because they weren't all together and it was taking forever. And I was like, oh, I should do description instead because trying to scroll through this is going to
Yeah,
be, and I'm going to miss something. And yeah.
you don't want to try to build a list necessarily, so I'm going to pick it from this list. So there's my spots. Let's create PVMT, pavement points. I'll unclick that and choose by description. Again, I'll set my list, and I noticed I had some EP. There's my edge of pavement points. Now, here's a point down here that says EPPC and EPPT. That tells it starts a curve and stops a curve, but it all has an EP on it. So if I just say EP and say OK and hit save, well, I may look at this and say, well, I got all my edge of pavement points. No, I didn't. I've only got the ones that have EP and nothing but EP in the description. So I'm going to edit that group. I'll double click pavement again. And instead of EP, when I look at this list, I see I've got some that start with EP, but they have some other things over here. I'm also going to look and see if I've got some points that might have been double coded, because maybe somebody picked up a driveway point, which that's that PV, that's my pavement. And they also said EP because it was a point in common between those types. I don't see that condition. So the only thing I really need to do is come back here and say EP asterisk. So anything that starts with EP and ends with anything. And now you see I've picked up those extra points. Now I also had in that group of points these things called PV, which were driveway points, but they mean pavement. So I've got a pavement group. Well, I'm going to also set that PV points and make sure there's some PVPCs. And so if I say, okay, whoops, I need to actually do.
Your screen might be frozen for, oh, okay. Now I can see. Yep.
So if I set from the list, I'm going to choose my EP points and I'm going to choose a PV point. So I'm going to control click. So now I've got two of these selected. I'm going to say okay. And because I know they also have some suffixes and other codes, I'm going to just click right here and type an asterisk. So that's a description, comma, description. There's no spaces in between them. It's just separated by commas, and I'm putting asterisks there, and then I'll save that. And now look at my pavement points. I've got PVs, PVPCs, and I'll scroll all the way down, and I'm going to pick up EPs, EPPC, and EPPT. Okay. So you can work your way around creating these. If I create another one, let's see. I always like to have one that I just call all points. It's not necessary because you've got that switch available as well. But the reason I do that is because I can not have to exit this and go and look at my points. I can see there's all my points. So then I can put things like control or in here. I've got utility points. I've got UP. So I'm going to make let's just call it utility. Oh, not include all. I will include from my list these things called, let's see, what did I have? There's a manhole. And there was a utility pole. So I control click that. I don't see any other codes. There's a light pole. So I'm going to control click that one. All right, so that's my utilities. Save that. If I create another one now called sewer, I'm going to include my manhole point. So I'm going to, and by the way, if you, you can click these different buttons and sort by those different categories. So if I sort by description now, they're all in order and I won't miss something alphabetically. So there's now, so I don't have any other MH otherwise, so I can just take MH. And that's going to be my sewer point. So there's 52, 3, and 4 are in sewer, and they're also in utility. You see them right there, 52, 53, 54. So they can be in more than one group. Okay. If we let's go back and redefine. First of all, we know utility includes utility pole, light pole, and manholes. Okay. Sewer, we said just manholes. Well, let's make one more of this utility. Let's create a group and let's call it poles. Now, in this simple case, I could go to description and say, you know, set from that list. What do we have? LP. There's an LP manhole and a utility pole. All right, so if we do that, that means look at all three of those. But from those group, now I can further restrict it. I'm going to, even though that's all, everything that I use for utility poles, I can go to exclude now, and I want to exclude my manholes. So it first included all of these, and then it's going to exclude those. And when I say that, now my poles group only has utility pole, and light pole. So the key to all of this is to figure out what you're going to include. If you want to include everything, so let's say we have a group called everything but utility. So now I can include everything in my include part, go to my exclude, and let's exclude by my light pole, manhole, and utility pole. Save that. So now everything but utility has all of those, which includes everything except those points that I defined in that group. So that's how you create those and you filter them back and forth.
And
Using,
then is there an easy way to turn those into layers or add like you know, a set symbol and line work
yes,
that way? Okay.
yeah, but that's generally done using field to finish. And that's you know, it's actually part of the survey class. We don't have time to go through and learn that part, but I would point you to that section in your help system. Just look for field to finish and see about learning to use that. You can also use that and what you do with field to finish is you create a code table and say, okay, if you have this code, you're going to go on this layer when I draw the point. And if you have this code, not only will I draw the points, but I'm going to connect lines between those codes if my code says to do that. Okay, and then as part of your points defaults, you can say down here that you want to use field to finish for your point styles, and that lets you choose a specific symbol, a specific layer based on that field to finish table, and you have to give it the code table down here. And that tells it to read the points, read the descriptions, and if it matches whatever this code is in my code table, it will choose a different symbol than the one I've got set for my default, and maybe a different layer that it's going to go on. Now, this doesn't control the line work here. This is just for points. But in my survey field or my survey system, if I draw by field to finish, and I'll just edit a code here. You see, I've got these, here's a tree code, for instance, and I said, if you have a description called tree, well, those are points only. Let's find, I don't know that any of these are defined. They're not. But you could say, and you could call the code here, you could call it anything like vegetation. And then you could look for a description for these points called tree. And then you could say, well, trees is a bad example. Let's say electric line or power line or a sewer line. You can say, if you see an MH, draw it. Let's, in fact, let's just make one. We'll add one here called a code called no, we'll just call it an MH. So that's going to look for my coordinates and it's going to see this MH. And I'm going to just say that is going to represent a manhole. And if I put a description here, that's going to, I may say sand, sewer, MH, or spell it all out, except I would spell sand correctly. And give it a layer to go on, draw points and lines, either 2D or 3D or 3D and 2D. And then I would tell it which symbol to use. I would switch it to be, say, my inlets and manholes, maybe use, get back to where I was here, inlets and manholes. And, maybe my mapping, I want to use this S for a sewer manhole. And then I would choose a line type either by layer, or I can pick from a list of all of these different kinds of various line styles that I can create and use with it. Okay, and so all of those things are controlled and they govern what happens when it runs across a point that says MH. And I've got extra codes I can add on to my points in the field where I can say start and stop, or start a curve and end a curve, those kinds of things. And that's what governs bringing all this stuff in automatically and drawing the lines and the symbols and the layers and everything correctly, not just the point groups. Now I can use point groups in this fashion. I'm going to switch back to my coordinate file that I'm using now, set my coordinate file to my stockpile points. So now if I were to draw locate points, let's do this. I'm going to, first of all, have it erase and redraw any of these points. So I'm going to have it draw stockpile points on the interior. That's going to be the layer name it's going to go on, and I'll leave it as these little X symbols. And I'm going to say draw point group, and I'm going to choose my interior points. Bada bing, bada boom. So now they are there. Oh, let me see. Sorry, I needed to have erased these first. Let me set my drawing setup on 20 scale. 1. MSLT scale is on. And then let me set this up to be 1 inch equals 20. All right, so now I could draw, locate points, set it on this layer, use this symbol, draw a group. There's my interior points. And so there they are. And then I might have another layer here. If I look at my layer now, I put that on SP interior. I'm going to make another layer called SP toe. And let's make it magenta color, for instance, and we'll give it some weight. I'll also do these interior points with a weight. And so now if I draw locate points again, I'm going to, instead of doing that in SP interior, I'm going to do SP toe and maybe switch to a different symbol. Go back here to my points. Instead of using that X, something else that might be more indicative of what I'm trying to draw. In this case, let's just use, let's use a plus mark instead of a X. Going on SP toe, and I'm going to draw that point group as my toe points. So you see they're now on a different layer. I select it, I see up here it's on SP toe. It has that color. It has that symbol. And if I select this point, it's on SP interior with the color that it's defined as, which is yellow. Okay. So that's a way you can use groups, is to help you in your point drawing and point controls, but not necessarily to draw lines between the points. That's more from field to finish. Okay. Now, so we've seen a bunch of these point manipulations and point groups and how to draw and how to shrink wrap different things. So again, we're back to, we need to finish this stockpile. We need a boundary around it. So again, you could just draw manually. This is a small enough site, or you could just draw a shrink wrap. Draw a shrink wrap boundary, shrink wrap your entities, and we'll say, okay, and we'll grab everything here, let it do its thing, and then we'll check it. And here's a place where it didn't put one there. So I'm going to add that vertex into this polyline. So I'm going to select it and get my grips up, hover in that mid grip and choose add a vertex. And I'm going to go up here and I need to make sure I snap to that point. Well, I'm going to see when I touch that letter O, it snaps over there and I get that little pop up. Remember what that is coming from? That is coming from this settings point object snap on and off. So that allows me to make sure I get the dead center and I don't accidentally grab the endpoint if I've got endpoint snapping on and stuff like that. So now let's just look around by inspection, make sure that we're looking at toe, 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 toe. Oops, there's one that's not a toe. So I need to remove that vertex. So I select it, the grips are on, I hover in the grip and I just remove that vertex. And say toe, 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 toe. All right, so that is a perfect little boundary for my stockpile. So now let's go back to triangulate and contour. So we'll go to the surface menu, triangulate and contour. Everything is now set up the way I wanted. I've got my file written called SP. I'll draw my contours. I'll label those 350 feet. I might want to tone this text height down a little bit. Let's make it 0.08. And we'll say, okay. Okay, to overwrite the existing file. Yes, it is. It now, oops, sorry. Escape and repeat the command. What I forgot to do was turn on the triangulate tab. I want to use inclusion exclusion areas now because I've verified this line here. I don't have to rely on it to do it for me. So I'll say, okay. Okay to overwrite. Now, select entities. It says select the inclusion perimeter polylines. Well, there it is. I hit enter. No exclusions. So that's what it's asking me on the line above. So I hit enter for none. And now select everything I want to triangulate. Boom, boom, there it goes. Oh man. What happened here? I must have said 8 instead of 0.08 or 0.8 instead of 0.08. So I'm going to go back to my surface menu, and instead of running triangulate and contour again, I've already made the file and it's trimmed to its proper boundary. So I'm going to just contour from tin file. I'll choose my file. Now this time I'm going to make sure I erase previous entities. I'm going to turn that back on. And I'm looking at my labels. Oh, there it is. I say 0.8. So 0.8 of an inch tall. I want those to be 0.08. I'll say okay. Select my inclusion, which I don't even need that anymore because the surface is already built, no exclusions. There it is. There's my labels. Everything's like I like it, and I can be done. Now remember, I've turned on that little issue of erasing the previous contour entity. So if I do anything else with drawing some other contours, I might want to keep an eye on the fact that I've already set that accordingly. So now at this point, you might even consider, all right, those are my existing contours. I'm going to go to my layer control. And I'm going to see these are the contours that I just created. Or it built the layers for me and it drew the contours. It made the indexes red and the intermediates white. Well, I might want my index contours and my contour labels. I'll select both of those by control clicking. I'm going to change their color from red. I'm going to make those a sort of this second gray icon, third one from the end, not this blank one, but the second gray one. So it's a color 253. Say okay. And I might want them to be a little bit, so that's my label. So I may want to set my label line weight, since I'm not using a true type font, maybe give it a little bit of weight. Set my index. I'm going to give it a little bit of weight, not quite so heavy, but a 0.3. And now my intermediate contours, I'm going to change that color. Instead of this second one in, I'm going to skip down to maybe 2 more to the left of it and say okay. And I'm going to give it a real skinny looking weight. And there now you can see they've toned down the color selection a little bit. Now, one other thing, existing contours are often done as dashes, right? So if I go back to my layers and I want to use a dash line pattern for my index and my intermediates, right now they're set to continuous. So let's look at my index contours. If I click that, well, the only thing I've got is this dashed 2 and continuous. So I need to load, and this is strictly CAD stuff. This is not Carlson stuff. So I need to load some line styles. So I'm going to hit load. And right now in this particular file that I can change to from the browse button, I've got all of these defined line styles in here, and you can see there's quite a few. Now this particular one happens to have, I might want to add in some, say, borders and centers, and the two I'm really looking for. So let's see, border, boundary, center, center, center. So I'm going to shift select those. I'm not going to look for cold water, blah, blah, blah. But the ones I'm really interested in, I'm going to control click on contour and contour 2. So those are dashed lines, but they have longer dashes and smaller gaps. So now all this is going to do is put that now in this list that I can choose from. Now remember, I'm defining this index. So I want to have my index contours have this contour line style, longer dashes. So I'll say okay. And my intermediate contours, I want to say contour 2, which is smaller dashes, and say okay. And now when I come out there, they look like existing contours a little better. I'm going to go one further step here. I'm going to select similar and I'm going to change the line type scale for those so that I've, excuse me, sort of miniaturized that line type. That's just cosmetics. It's nothing you need to do, but it might help you out as you're looking for stuff. Now, remember these points that I used to build the surface with. And I put a boundary around it. And of course, these points are also included in the surface. And that point on the interior, that makes that surface. If I look at that surface now, you know, there it is, trimmed up to the edges that it needs. You can see the triangles. All right, so that's now my stockpile, and it comes into those toe points like I wanted to see it. So that's now that surface. All right, so how would you compute the volume of this surface? And the answer would be, if I'm going to, well, here's something else I want to look at. See my little label up here. I'm going to get that off that corner. So I'm going to go back to surface, look at my contour utilities and move the label along the contour. So I'm going to take that and just slide it down here a little ways. It's okay back there. See if there's any other odd placements. That one looks okay. That one looks okay out there. I'm happy with that. I'll hit enter. All right, so now if I want to compute the volume of material in this stockpile, I need to compare this surface to an existing ground surface of everything that exists out here. Well, I don't know anything about that, right? So how would I figure out what this thing is sitting on? It's sitting on its base. And so I might want to take the approach of creating another surface that is just these toe points and not choosing any of these points in the middle, but just look at these points and let it make triangles all the way across the bottom. So that's going edge to edge without climbing up and climbing back down. It makes a surface that this thing is sitting on. It's the base of my stockpile. Okay, I'm going to change this up to be a little lighter. I think it's a little hard to see. There, a little better. Okay, so I might want to create a surface out of that bottom layer. Okay, so how would you do that? If you want to then select those points and make a surface out of just those points. Well, if you go to triangulate and contour and it asks you to pick points, you don't want to have to meticulously pick all those points. You want those by themselves so you can pick them. So I'm going to go to view and I'm going to isolate my layers, and I'm going to pick one of those toe points, and I'm also going to pick the boundary because I'm going to use that same boundary. And now when I triangulate and contour this data, none of those other things are in my way. So I'm going to go back to surface, triangulate and contour. And on the triangulate tab, I'm going to write the surface file. So I'll turn that on and I'm going to select it. And this time, instead of SP, I'm going to call it SP-base and save it. Okay. I will use inclusion exclusion areas. I'll ignore zeros, but I'm going to go to my contour tab and turn that off. Now, even though I'm not drawing contours, right now, under this control on the triangulate tab, it says erase previous contour entities. Well, that should say surface, not contour, because it erases drawn triangle edges, boundaries, everything that you've drawn related to a surface. If it's set to do that, it will erase those ones we just drew and rearrange the text placement. So I'm going to turn that off so that even though they're frozen, I don't see them. If I had that on, it will get rid of them. So I'm going to make sure that's off. And even if you accidentally do get rid of them, just go back to surface, contour from tin file, and just redraw them. So now I'm going to erase those are set to off. So it's not going to erase. I'm going to build a surface. I'm going to say, okay, I'm going to pick my inclusion perimeter. No more inclusions, no exclusions, and then grab everything here and say, okay. And it has now built a surface file called SP base, and it looks like that. It's basically flat. There's a little bit of a kick up right up here in this one corner where that one point might have a bad elevation. We don't know, but that's the toe of the slope. But there it is. It's basically flat, and you can compare it to, I'm going to the model tab. I'm adding the other surface. There's my stockpile top. And here's where that little flip up happens with that corner out there. And you can see one surface, there's the base, and there's the top. Okay, so now what that that little flip in that upper corner up there that you see, because the stockpile is actually buried a little bit underneath the base right in that location. So when we compute the volumes, you're going to get a very small amount of cut instead of fill in there, which you can just ignore in that particular case. All right. Now, what else could we have done here? If we had drawn this line, instead of as a 2D polyline, if we had told it to shrink wrap and draw a 3D polyline, I could have built a surface out of just that polyline. I would not have even had to include these points. I wouldn't have had to isolate my layers. I could have just used that as its own inclusion, selecting the entities to triangulate. I could have just picked that, and because it's a 3D line with elevations, it goes to all of the different vertex places along that boundary and creates the triangles across the base. So either of those would work. So let's go back to the view menu now, and let's restore layers so it puts it back to the way we had it. Now we're through really looking at our points. I don't really need to see them anymore. So let's just freeze off those layers. So I'm going to say, I'm just going to go to my layer control, and I'm going to find those particular point locations, which I had SP enter and SP toe. So I'll shift select those and hit the little sunball to freeze them. And now they're out of my way. I now have a good representation of my stockpile surface. I've looked at my surfaces, they're there. And if I want to see what the volume of material is in here, I'm going to go to surface, volumes by triangulation, to triangulation surface volumes. And it wants you to select an existing surface. Now, even though the stockpile does technically exist, I'm going to compare an existing to a final, and my existing is going to be the base. What is this stockpile sitting on? It's sitting on its own base. So I'm going to select SP base as my existing. I'll say open. It's going to immediately come back and ask for another surface. This time, you see up here in the top, it wants you to select the final surface. That's my SP. I'll hit open, and now it's calculated all of that. Select any inclusion polylines, so I could only be looking in a particular area, but I'm going to say enter for none because it's only going to go out to the edges, no exclusions. Cut and shrink factors, if you know what they are, what kind of units you might want to use, cubic yards for the volume, square feet for the area, report tons if you knew, this is limestone maybe, 120 pounds per cubic foot, give me the tonnage for it. Do all of these different things, but that's really all I'm going to do. I'm going to say okay, and here now is my stockpile volume. Notice there is a very slight 1.7 cubic yards of stone. That's where that little flipped up corner was that says I have to cut. the base to get down to the stockpile surface. Now, it's small, even though, 2 3/4 tons is still kind of heavy, but it's still just, it's less than 2 cubic yards. I have 3,200 cubic yards or 5,300 tons of stone. That's my volume. Now, a couple of things that this will do for you is in your volume report, you're always going to get this little averaged area here, and it says, okay, I've looked at these two surfaces, I've given you your volumes, and I'm saying, if you want to balance that site out, you would have to take that floor, it computes it as if it's a cube with straight sides, and you would take that floor and raise it up essentially 3.5 feet, or not, you take the stockpile and drop it down 3.5 feet, and that would balance the cut and fill. And it says for every 1/10 of an inch of height that you change, every 0.1 foot, you're going to change the volume either up or down by 93 cubic yards. Down there's my density that I use to compute it with, and some other statistics. Now I'm going to choose this button right here that says output to screen. And I'm going to take these defaults. I'll use a 4-foot text height. That one happens to be actual CAD text height. So I'm just going to come over here and click a point, and then I'm going to click another point, click enter to drop it, and then I'm going to exit my report. So there's my volume report using two surfaces. Volumes by triangulation. There's the numbers. Now, what's another way we can do this? We can go to surface and choose volume by triangulation. One triangulation surface volume. So we're just going to look, we only built the stockpile, we didn't build the base, we just did the stockpile. We said open. And now, what do you want to reference that against? Either a known elevation, like if we're down and it's relatively flat, we could find an average elevation for the base, or we could use the actual perimeter of the surface we're looking at, and that's going to be exactly the same as the base that we built. So I'm going to say, okay, take those same values, say, okay, get my number. There's the same 1.7 yards of cut, 3265 yards of fill. So that's the very same number. I can, plop it down here, exit, and you can see those numbers are exactly the same. So that was the very same methodology. I didn't have to do the base, but we did just in case we needed it. And that was one of the approaches. The other approach is you could figure out the average elevation around the edge. And the way you would do that, we won't go through it, but we would draw, instead of this being a 2D polyline, we would shrink wrap those outside points and make it a 3D polyline. And when you do that, and you go to your inquiry menu and look for polyline info, it will give you the average elevation of that 3D polyline all the way around its length. Okay, so it would report that number, and then that would be an average elevation. And if we chose volume by triangulation, one volume, we looked at our SP and we said by elevation, that would be the number we'd type right in there, and it would come up with the numbers. Now, the numbers would be close to these. They won't be exact because it's averaging it out. So you're going to get some over and some under. And so you would see those numbers to be slightly different. Now, the other thing about stockpiles and ponds as well is on the surface menu, you actually have a little stockpile. Do we have it here? No, it's not in survey. In civil, I'll just show it to you here. You have this under its surfaces. You've got these stockpile commands, stockpile and pond and pit volumes. And you can calculate the stockpile volume, and it basically goes through the exact same thing that we just went through, except we don't have to build the surfaces. It builds it on the fly, looks at the outside perimeter, and throws all that stuff away. But we're going to use that file for something else. All right, so we're going to go back to survey. Now, if we're going to, like we see in the book here, and we've gone to this point here, there's our boundary points. We built the stockpile surface. Here's our computing volume, little discussion, how we cleaned things up and did it. Got the reports. So now we have that file. So we're going to do a borrow pit. We're going to design a borrow pit that goes into our surface. Okay, and we're going to use a command to do that called design pad template. Okay, and I'll show you how that works. So we're going to draw a little outline that's going to be the bottom of our borrow pit. Excuse me, or maybe it's a pond or whatever. And then we're going to tell it to go out and seek this surface with certain side slopes. And excuse me, when you do that, then it can calculate the volume that comes out of that, and we'll see how it goes. All right, so oh, excuse me, I'm so sorry. I lost my voice here. So we're going to run through that now as the last bit. I'm going to select these reports here and just get rid of them, get them out of our way. So now what do we have? We've got our surface, we've got our stockpile surface. So we're going to design a little borrow pit or maybe a pond or something here in this surface. So the first thing we want to do is we're going to draw an outline that's going to represent the bottom of the floor of that surface. So we're going to draw it as a 2D polyline first of all. So we'll draw it 2D polyline. And I'm going to uncheck this use current, and I'm going to come down here and I'm going to put it on a specific layer, and I'm going to call this my pit outline. I'll say okay. So now I'm just going to draw. I'm going to turn off my snapping by double clicking over here so that I can just draw without snapping to stuff. So I'm going to draw a figure that looks sort of like this. And you can do the same thing. I'm just sort of come in here and I'll type C to close. Now I'm going to go back to my layer control so you can see that my, what did I call it? My pit outline, I'll make it this sort of orangey looking color, give it some line weight. So now that's going to represent the bottom of my pit. I'm going to select this and I'm going to grip edit it just a little bit here to sort of get a little bit closer to this edge. But I'm going to pull this back a little from that edge because I don't want to run off my surface when I'm trying to catch the slope. Okay, so there it is. Something like that. Now, I'm going to wind up needing to set this particular bottom at a particular elevation. Right now, you can see my 400-foot line goes through, basically through the middle. That's 401, 2, 3, 4 up here to the peak at the top. And it's down, it goes to, 399, 98, 97, 96, a little bit above 95 in here. So I could decide if I had a target in mind, I could maybe make it 392. So it's 3 feet deep in the ground right in there. And it comes out around all the way around it. But that's called this surface menu, this design pad template. So let's do that first. And I want to set a several things here. I'm going to set my target surface as as a surface file, not the screen entities, but the surface files that I've already made. And again, if I'm drawing it from the outside down to a specific elevation or something, I could have it seek a particular elevation and stop. But I'm going to go up here and intercept this surface around the edges. And I'm going to go, my direction is going to be to the outside. And I'm going to choose my side slopes as being as a ratio, like 2 to 1, 3 to 1, what have you. Okay, so I've got those three checked on. I'm going to come down here to the bottom. I'm not going to do any of these particular extra little nuances. I'm going to also uncheck to calculate the earthwork volume and calculate the pad. I'm not going to do that yet. I will round the corners. I will not erase my previous pad entities necessarily. I could if I'm going to play around with it and try some different iterations, or I can hide the pad, you know, all kinds of little controls. But I want to round the corners. I want to draw the side slopes. I want to color the side slopes. And I'm going to space those side slope polylines every 10 feet and go around the corners at a 10-degree angle sweep. I'll leave my shrink and swell factors as 1. Trim existing contours inside pad. I'm going to say no. That would be like erase by closed polyline on the inside. We did that earlier today. And I'm going to put this on a layer from my pad. I'm just going to call this my borrow pit. That'll be a layer that it's going to create for all of the 3D lines you're going to see happen. I'm going to say okay. It says now pick a pad polyline. So if I pick that pad polyline, it says, okay, I know you're going to make a pad out of this. What surface do you want to intercept? Well, I'm going to intercept my stockpile surface. So that was my target. And now it wants to know my fill outslope ratio. So I'm going to say, let's try 3 to 1 slopes. So I'll enter to that 3 to 1 slopes here. You can make it steeper, 2 to 1, 1 to 1, 6 to 1, whatever. And now you need to set an elevation for that pad. And it tells you by reading the surface that it goes from 395.12 up to a high point of 404.4. What do you want to set the elevation to? And it sets it as a suggestion at the lowest number it finds. Well, you set it to whatever you want. So let's say if we set it to 400, for instance, just as a sample, and that's right in the middle. Okay, so if I say 400 and hit enter, it's going to draw, and I'm going to say no to adjust the parameters and redesign the pad. So it's going to draw these lines, these 3D lines. Let me go and turn those on so you can see them a little better. My borrow pit, make them a little bit heavier here. So there's now the ponds and or the 3D lines that would be built. And if I were to look at this in 3D, which I would often do to check it with my 3D viewer, I can see that the points down here on this edge are above the surface, so they're blue, they're in fill, and the points back here on the backside are below the surface, so it goes up at 3 to 1 until it daylights, and that area is in cut. I can also look at that separately like this. If I look at my surface and then go out here and add, oops, I'm going to add say those and try to get rid of some of these. Anyway, there might be a few stray contour lines in there. So there's now my contour lines, and if I, or my 3D lines, you can see some are above. Let me turn this on and set my model transparent here a little bit. or a little bit transparent. So now I can see through it. I see that the lines that I would create are sticking up in the air down here in the fill area. And back here, they're in cut. All right, so that is if you notice, I set the elevation at 400. Look at where my fill ends and my cut begins is right at that 400 mark. Same thing around here, okay? Now, the next steps of what you would do would be to build a surface out of this and compare that surface to the other surface. So I'm going to go to view, or yeah, view, and I'm going to isolate layer, and I'm going to just pick one of those blue or red lines. And there is what I'm going to use. Again, by verification, I can see, yep, it's in fill and in cut. So if I compare one to the other, it's balanced like right across that mid-level. And if I build a surface there, and I'll do this real quick, you don't have to necessarily do this. I'm just doing this for as an example. So I'm going to build another surface, triangulate and contour. I'm going to select it, and I'm going to call it this one pad. Use inclusion exclusions. I'm not going to contour it. I'm just going to build the surface. I'll say, okay, I'll build this. There's my inclusion, no exclusion. Grab all that data because it is 3D. I've built my surface. I look at it here now called pad as a surface. Let me go back now to set the opacity back so you see it a little better. So there it is. There's the triangles it built. You see the fill slope, you see the cut slope in the back. You can change your shading to get some different sides. All right, so that would be that surface. And then if I computed volumes by triangulation, two surfaces, I'm going to choose my stockpile as my existing surface. I'm going to choose my pad as my design surface. No inclusions, no exclusions, run the report. And here it is. I've got basically 558 yards of, or 344 yards of cut and 447 yards of fill. So if I wanted to really balance that, I need to drop that top surface by 0.235 feet, and that would get me closer to being balanced. Now let's look at one last little command here that we can use to do that with. If I go to my surface menu and choose triangulation file utilities, it's a very powerful command. We use it to merge surfaces and adjust surfaces, things like that. So I'm going to load that pad file and open it. There it is. You can see it. I'm going to go to the next button, and I'm actually going to exit this because I forgot what that number was. So I'm going to display my last report. So that was 0.235, negative 0.235. I got to lower it. 0.225. Okay, so back to triangulation file utilities. I'm going to load up pad. I'm going to go next. Maybe I'll color that in. And I want to subtract a value or another surface. I'm going to subtract a value of 0.235 feet. That's going to lower that pad. I'll say, okay, boom, it did it. I'm going to do a save as, and I'm going to call this one pad dash lower. Save that. It's now been created. I can exit that utility. And now I run my volumes by triangulation, two surfaces. This time I'm going to take my stockpile again as my existing, but pad lower as my final. No inclusion, no exclusions. Get my volumes, and now look at the volume, 395.27 compared to 395.45. So that would exactly match what that needs to be. just if I did that surface. Now what's happened though, this line around the outside edges represents where my pad with the elevation of where it used to be, which was 400. Now, if I look at that and I see that elevation, well, that's still at 400. Oh, I haven't drawn any of it yet. So, but if I were to look at the lowered pad, that number would not be 400. It would be 400 minus 0.235. So it's a little bit lower. And then this line would naturally be a little bit further out because it started out lower. So it would be sort of an iterative process. You can't just create that surface compared to the other one because you've modified the one, but now the daylight line is going to be slightly different. Now, in civil, you don't have it in survey, but if I switch to civil, you have a command under surface that is not just design pad template, but you've also got edit the pad template. And if you do that and choose that pad, now that's the original one at 400. You see here 3 to 3, 400. If I process it, there's my original volume numbers. And if I want to balance that, I'll say, okay. You saw those little outside edges, you might have seen it shrink in a little bit. And now you see I'm at 395 and 395. So I'm balanced. I could then write that 10 as an adjusted value, but notice it dropped up here. It dropped the elevation. There's that 0.235 dropped down from that original 400. So that would be an example of how you would do that. Now, you could, and so the civil module has that tool and it's real handy. You can move it and it just recomputes everything, on the fly. We don't have it. We're not going to worry about it. And we're going to restore our layers here. And so that was if we set it sort of midway along there. Well, let's do that same process. But this time we're going to set it down as a sunken depression down below the surface all the way around and compute the volumes. So the first thing to do is let's get rid of these lines out here that was from our first go. So I'm going to erase by layer. I'll clear my list, select it from the screen. I'm just going to pick one of those little pad lines and say, go away. Now there's my original, still sitting at 0 elevation. So let's do surface, design pad. Let me switch back to survey here. Surface, design pad template. We'll keep everything just like we had it before. We'll say, okay, we'll choose our pad polyline. We'll choose our surface target. That's a stockpile. We'll keep the 3 to 1s, 3 to 1s. And now the elevation, let's set that bottom floor elevation instead of 400. Let's put it below this 395. Let's maybe call it 393.5 just for yucks. So if we do that, do I want to adjust and redesign? I'll say no, because now everything is in cut. And if I look at this in 3D, you can see there that it all would be down there in cut. So I would go right back to isolate my layer, pick one of those, build a surface from that, triangulate and contour. I'll keep the same name, which is pad. Say, okay, yep. And I'll choose my inclusion, no exclusion, grab everything here, let it build, verify it with a view. There's now pad. So it's now completely under the surface. I can compare it against my stockpile surface and change its opacity a little bit here so I can see underneath it. I'll put it back. And exit and we go. All right. So now we go back to our volume by triangulation, two surfaces. So how much dirt do we take out of our stockpile to create that sunken pad? So I'm going to choose my stockpile as my existing. My pad is my final. No inclusions, no exclusions, hit my okay. And so I say, well, I need to cut 2,700 yards of material. I don't fill. And here's my average. I'm basically an average of 5.5 feet deep compared to the average of the surface above it. Okay. So that tells me the volume of material to create that either as a pond or maybe a borrow pit. And so what happens if you, let's say we saw that report, it said we had 2,700 yards of cut. Let's say it's a borrow pit. Maybe if I need 3,500 yards of material to put on my site somewhere else. So how do I take it from that to 3,500? Well, 2,736 up to 3,500 is what, about 800 cubic yards. I look at this number here and I say for every 1/10 of a foot, I'm going to get 50 yards. So 800 divided by, 50. So I need to get 16 of these units. So 16/10 or 1.6 feet. So basically, if I were to go back and redesign this thing, but lower it by 1.6 feet, and then compare the volumes, I would be getting closer to my target of 3,500 cubic yards. Okay. So that is basically the process. Let me now restore my layers back. And what you would do if you're going to draw that, like I might freeze off that particular set of line work and then contour from tin file. This time I'm going to use the pad. I'm going to make sure this is off for erasing. I'm going to set my contours, and this time I'm going to draw it on a different set of layers. I won't label it at all. Just draw the contours, say okay. No inclusions, no exclusions, and there now is my grading plan. So that contour right there is at 399. That's what it ties to on the existing contours. Then it goes to 400, 401, 402, 403, 404, or I'm sorry, it's going down. So 99, 98, 97, 96, 95. So this one then is at 395. All right, so there's that set of drawn contours. That's the grading plan to create that. Now, we are at the end of our lovely time together, but let me point you to a couple of things here in the book to continue working with this to finish this whole thing up. And all of these from this section down here, we talk about drawing these contours. Oh, one last thing. I will show you this one. And so we're drawing the contours for the pad. We got the existing contours underneath it. We also can take the pad outline and trim off the existing contours inside it, even though we haven't cut a hole in the surface there yet. So all those different variations. And then it steps you through building a center line, cutting a profile through the existing surface, and then designing a little road profile along that. And you can see from this green outline here, I come up here and I turn into this pad, and it's got these downward sloping sides.
And you see that over here in this existing ground profile along where a road needs to go from here down to here. There's the pad elevation, and there's that downsloping side that would cut. So we would target that we want to land at that elevation. We would draw it as a 3D polyline, offset the edges. All the commands are in here. Okay, and then we would contour that as a little surface, add it to our surface. Okay, and that concludes that whole thing. And here's how you add those surfaces. Remember the two surfaces that we have? We have the stockpile, we have the pad. So if I wanted to combine those into an overall total final surface, I'm going to do that from my surface menu. Triangulation, file utilities. I'm going to load up as my first file here. I'm going to use that stockpile, which was sort of my existing ground. There it is, like we had it. I'm going to go to the button at the bottom that says next. So I'm going to the next page. And let me, yeah, there we go. Switch it back here. I just want to, there's what I'm trying to do. So now what I want to do is to take that pad surface and merge it into this surface. I'm not going to add it. That means I'm going to add to it, above it, but I'm going to merge it. And I'm going to take these choices. I'm going to say my second 10 that I'm going to pick in a minute is the inside and the outside. The current 10, that's what's loaded now, is the outside. And I got some transitions, different ways you can adjust it here. Set the colors if you want. Say, okay. I'm going to choose my pad, and you see what it does is it would be, this would be the resulting final merged surface if you did that. So we're going to do that. And down here below, we want to output the insides, which is the green part, the outsides, which is the white part, and the border, which is the outside border. And we just say save as, and let's call it this time SP dash merged, and say save. We'll exit that. And let's view that surface. So I'm going to go to my 3D surface viewer, SP merged, and there it is. I can even look at my contours, and that would be the resulting grading plan with 1 foot contours. And that is a single surface by itself. You can contour it, you can compute against it, calculate volumes to it, all kinds of stuff. So if you were then putting another pad above this surface up to a certain height, like think landfill. So if I filled this up here, then I can calculate the volume between this surface, which includes this new basement, all the way up to the top, which would be the top of my trash pile. And that would give me the volume that I'm looking for. Okay. Clear as mud, coming down to racing into the finish line here. But take a look at the remaining steps that you see here and give it some practice. And, you know, they should help gel all of those different processes that we've been doing. But I hope you get a better comfort level with working with this stuff in 3 dimensions. Always, always, always use those 3D viewers where you go, you know, verify your views, make sure you don't have any goofy looking stuff. Okay. Look at your surfaces, make sure everything looks good, make sure it passes the sniff test. You know, do one of those quick profiles, setting the pad against the existing ground, for instance. Pick a point across it, and there you can see, you know, the way that would look. Adjust the position. You can see as I do this, I'm actually cutting those different surfaces in real time as I drag this thing around. Okay. So any of those ways to help you verify what you've got done and how you've built that surface, okay? Now, once that's done in a particular spot right here, you can even draw that out here. I'm just going to take the defaults. I have no idea what these are set up to be. I'll put it over here, and you know, it would draw. You've got all kinds of control over the scaling, the layers, the styles, the grids, the spacings, and all that. But you can see I can even document that little profile that I cut across there. So there's all kinds of tools that we just don't have time to go into in much depth in 2 days. But play with it. Try those things. If you're not sure what they do, look it up in the help system, or just do it and then undo it if it doesn't do what you want it to do. Okay? Questions? Anybody? Everybody good? I'll give you guys an extra half hour in your PDHs. Fran, I think you might be the only PE in the group, but that'll add to your total. So instead of 13, you'll get 13 and a half.
Okay, thank you.
You betcha. So if nothing else, I will bid you a great weekend. It's actually my son's 41st birthday today, and we're going to go down and he's going to cook us food on his grill. So we're heading to that. But anyway, if you've got my email, if you got questions, get back in touch. You know, be glad to help you out and you know, help you ease through this learning process. It's not a process that ever ends. I still learn every time I use the software. I'll probably say that I would learn something new. I've been doing this kind of stuff for over 40 years, way back in the early days when there weren't that many tools to help you to get it done. So, you know, I can help you over those rough spots when you need. So just keep that part in mind. So stay in touch. Let me know any questions, and I will be sending out certificates of your training plus links to the recorded videos that go up to my YouTube channel. And they're the only people that can actually see them on that channel are those people that have that link. So it's only going to be you and your class that can see these particular ones. But once you have the link, you can always go back there. They'll always live up there. You can go back to them. So with that, let me stop my share and I will stop my recording.